ಶುರು ಮಾಡ್ತಾರೆ ಅವರು.
It is mark of our undying tradition to invoke the beginning of the important event.
Mari kanada
Philosopher said, the function of prayer is not to influence God, but rather to change the nature of one who prays. I call all the dignitaries on the dais for lighting the lamp. I request one of the participants to join.
Gautam, go to the camp. Go to the camp. Go to the camp.
Nothing can be more reassuring and heartwarming than affectionate words of welcome. So now I request Dr. Devraj, Vice Chair, IEEE India Council Educational Activities, to deliver the welcome address.
Honorable Chief Guest of this inaugural function, Dr. C. Vice Chancellor, Guest of Honor, Dr. Gopal, Dr. Suresh Nair, the Chairman of IEEE India Council, faculty members, volunteers of IEEE, and the participants of this today's capacity building workshop. Very good morning to all of you. Indeed, after almost 3 years, we are conducting physical event along with the online participants by the IEEE India Council educational activities team. In fact, for the past 2.5 years, we have conducted a number of technical activities through the educational activities team of IEEE India Council. In fact, many volunteers from here who have been supporting us. All the events were conducted through online, and it was very successful one. And now we got an opportunity to meet the people face to face and to conduct a technical program. I'm extremely happy to join with you all for the inauguration of this event. This event is organized by the IEEE India Council along with 4 more IEEE organization units, namely Student branch of IEEE SRM, Educational Activities Team of IEEE Pune section, Education Society of IEEE Hyderabad section, and Women in Engineering Madras section. And in fact, this event has been funded by IEEE Orton. First of all, I would like to thank IEEE Orton for sponsoring this event and for permitting us to host this event at the SRM campus. With respect to this capacity building workshop, dear participants, with the advancements in sensor technology and computing domain, many of our physical systems like electrical system and water systems, they are all becoming cyber physical systems, which help us to monitor them remotely and through continuous manner. So it is imperative for the future engineers to have a good understanding of these cyber physical systems. In fact, a lot of research activities are conducted by the academic institutions and as well as by the research laboratories. Many of the people in electrical engineering, computer science, they are all working on this domain. So to make the participants to empower and to educate them on the details of cyber physical system and the research developments on this domain, this capacity building workshop is organized. As I told you, it is conducted in a hybrid manner. There were around 350 registrations for this event. 120 people they are registered for physical participation, and remaining 220 they are joining through online. So this event is going to be inaugurated by Dr. C. Muthamil, Vice Chancellor of SRM ISD. Dr. Muthamil sir, even before taking charge as the Vice Chancellor, and when he was the Director END of this institution, he was very supportive, and even during that period we have organized few events from IEEE Madras section. So at this juncture, on behalf of the IEEE India Council, I would like to thank him for all the support he is providing to the activities. And on behalf of all the participants, I would like to welcome our Chief Guest, Dr. Muthamil sir. Welcome, sir. Next, we have with us Dr. T.V. Gopal, Dean CET, SRM ISD, to grace this occasion. I would like to welcome Dr. T.V. Gopal sir. Welcome, sir. Next, Dr. Suresh Nair sir, the Chairman of IEEE India Council, have joined with us for the inaugural function. In fact, for the past 2.5 years, he has been very supportive for all the volunteers of IEEE educational activities team, and he gives complete freedom to us in organizing the event and also in decision making related things. He is a true leader who supports all the volunteers. It is an honor to have our Chairman of IEEE India Council with us. On behalf of all the participants, I would like to extend a warm welcome to our Chairman. Welcome, sir. Next, I would like to welcome all the coordinators who have made all the arrangements for the physical event as well as for the online event. Dr. Sangeeta is making all the arrangements for the physical event. Along with that, Dr. Preeta Roslin and the team, they are supporting there in making the arrangements. Apart from that, the remaining 4 coordinators, they have joined through online. I would like to welcome all the coordinators for this inaugural function, and I would like to thank all of you for the support you have extended. Finally, I would like to welcome all the participants who are attending this event physically as well as through online. Dear participants, in the next 2 days, you are going to have a number of technical presentations and a few demonstrations related to cyber physical system design, modeling, and simulation. I'm sure at the end of the 2 days workshop, we'll be having good knowledge about this particular topic. I request all of you to make use of this opportunity to enhance your knowledge on this domain and to further your research activities in this area. With this, I would like to close once again. I welcome each and every one of you for this inauguration. Thank you.
Thank you, sir. Now I request Dr. K.R. Suresh Nair, Chairman, IEEE India Council, to deliver the presidential address.
Very good morning. Good morning. Good morning. Morning, you have to have a lot of energy. Evening, it's okay. Respected Vice Chancellor, Dr. C. Muthamil, Dean, Dr. T.V. Gopal, and Vice Chair, IEEE India Council Educational Activities, Dr. D. Devraj, and Dr. Preeta Roslin, Dr. Sangeeta, and all the loving participants. I feel it's a privilege to be here after, I think, 2 or 2.5 years of online meetings. So I thought that this time I think I should make it, because Dr. Devraj was insisting that we should come and physically present here. I feel very honored on that one. A little bit on the IEEE activities. As probably you may be knowing, IEEE is the world's largest professional organization. And we have 10 regions, and India comes under region 10. And under region 10, India, we have IEEE India Council and 13 sections across the country. And we have around 54,000 members. So those who are not members as of now in IEEE, please join, because you will have a lot of benefits on that one. I'm not going to explain those things, but you will surely reap a lot of benefits on that one. Now, coming to the R&D academic industry and all, because I started my career at Tata Institute of Fundamental Research as a scientist at that time. Then I was with Ministry of Information Technology for some time. Then I shifted to an industry, and I have been with an industry for 20 years, and then I took up my own entrepreneurship. So that was the career. So why I am explaining this is like I want to emphasize on the role of research, what you guys are doing as academicians. See, if you look at government funds the R&D in the country, you know, and you do a lot of publications and all. So what happens is like the output or from these research, the fundamental research or basic research, basic science, scientific research, the output what we are expecting are world-class publications, sometimes patents. So the output from these research should surely get on to the next phase, that is called the applied research. So you have some scientific results here, you have to get it converted to the applied research so that this will be useful for the society. And the output from the applied research should get on to the last phase, that is on industry. Okay, that is where they are coming up with a usable product, commercial product, and sell the product. Okay, so let us look at this loop. Right now, research is funded by government, that is tax money. The applied research is partly funded by government and maybe some industries, but the final last one is funded by themselves, the industry. No government is going to give a, except a few grants and all. So the purpose is like these commercial products to be sold. You make money and give tax and to the government so that the whole loop gets completed. Otherwise, what happens is like you have some publications and your resume will be looking good. That's all, but not to the benefit of the society. This is what I have been insisting. Like whatever research you do, please do tie up with the industry so that some products, usable products come up, so that it will be really benefit the society. For IEEE also, our tagline is advancing technology for humanity. So we are all engineers. So whatever we do, we learn. Are we directly contributing to humanity? So that's one way. One program is now coming up. You can look at our IEEE India Council. That's called MOVE. Mobile Vehicle Outreach Program. This is for, as an engineer, what type of help we can do during disaster. So that is one of the things. So what we can do, we cannot go and physically do some activities because our strength is not physical. Of course, physical is there, but technology, engineering. So IEEE India Council is now coming up with a program where we are planning to roll out a truck equipped with equipment. During disaster, normally a few things which gets disrupted are power and communication. So I have a lot of examples to say, but due to lack of time, I'm just leaving it there. So if we are, as an engineer, are able to support the frontline workers with, generator like power, supplying communication. So those are all a little difficult thing because diesel generator and things like that, solar panels and then generate. And you won't believe at this time, everybody wants their mobile to be charged. That is one of the major one. Okay, but that is a purpose actually. I have a lot of examples to talk about also. So are we able to give a provision in a truck to charge maybe 100 mobiles at a time? Okay, that is what we are going to come up. And when there is no disaster, means that's what we like it. This truck will be used for STEM education, science and technology, engineering and mathematics education in rural India. So these are some of the activities which are going on. And my last point on the subject, the simulation. When I started my career also, I was fortunate to associate with the designing and architecture of a radar system. Okay, in a radar system, the overall specifications. Okay, normally we can always derive that, but these system will have lot of subsystems like transmitter, receiver, so many things, signal processing systems and all. So from that, you have to derive the specifications of these subsystems. Okay, you derive. That's all done, theoretically and all. But when you develop that system, for example, you are developing a receiver system, so you will not get passband characteristics like a square and all. You will have some, practical systems are not like the perfect system. You know, it has got some rise time, fall time and all. So at that time, what we have done is like we put that achieved specification into the simulation model so that you know what happens to the overall system. So that was one of the, the fantastic thing, at least application, what I have heard or what we have enjoyed by doing the simulation. So similar here, cyber physical systems, anything like self-driven car or intelligent building or even a biomedical thing implanted, all those things are cyber physical systems. So I'm very glad that a lot of hands-on workshop as well as lectures will be there on this program, and I wish all the very best to the program. Thank you very much for it.
Thank you, sir. I would like to request Dr. C. Muttamil Chelvan, sir, Vice Chancellor, SRM Institute of Science and Technology, to deliver the inaugural address.
Very good morning to all of you. Respected Dr. K.R. Suresh Nayak, the Chair, IEEE India Council, Dr. D. Devaraj, Vice Chair, IEEE India Council Education Activities, Dr. T.V. Gopal, Dean College of Engineering and Technology, Dr. Sakita, Coordinator for the IEEE Student Branch at SRM ISD, other colleagues, and dear participants. I'm extremely happy to be a part of this inaugural program, which is going to create a lot of interest on cyber physical systems modeling, simulation, and analysis. Before I move on to say a few points, I would like to personally thank Dr. Devaraj for identifying SRM University to host this capacity building workshop. Thank you, Dr. Devaraj. As has been said by the other speakers, after about 2.5 years, we happen to have a physical meeting. And that too, if you look at the numbers, out of 350, about 120 are here and remaining again through online. I think you are most comfortable only through online. Now, the COVID has changed a lot in us. We never thought that all our classes will go on online, exams will go on online, lot of e-commerce activities will pick up, lot of new things will come up, lot of new technologies will come up. And therefore, I feel that we are more tuned to the technologies than traveling some distance, wasting time, and so on. Now, for the participants who are not associated with SRM University, I would like to highlight a few aspects of it. We are a multidisciplinary university where we run all programs. We are a multi-campus university. We have 5 campuses and close to 62,000 students are studying in SRM Institute of Science and Technology. So that shows the huge strength and potential of the young minds at SRM. Now, the cyber physical systems, they talk about interdisciplinary activity, and therefore I certainly feel that SRM is the right place to conduct such workshops. I do not know whether the participants from SRM are from all faculty, but still, if there are students from all faculties, it's a most welcome measure. We have been talking a lot about IoT for quite some time, and still we are working on that. When the internet was in place, Lot of devices has been connected, and that is the Internet of Things. Now, how do you exactly connect a physical system to a network or a computer component and things like that? So when you get into a cyber physical system, now cyber means everything and anything. Earlier we used to talk, now we do cyber talk, right? Using computer we talk. Cyber art, earlier we used to draw certain things, now you draw in computer. Space, cyberspace, space has become cyberspace. So this cyber means everything and anything that will not go away. As we go down the line, more and more new technologies will come up. There is a bigger challenge in adopting this cyber physical system. One is the design, the other one is the analysis. And that's because of the interconnection between the network, the physics of the system, it's not the physics, the physics of the system, and then the computer component. That's the biggest challenge. The other one is the security and privacy. That's also the other challenge. Though we have been moving forward in tackling these challenges, but there is still a long way to go in addressing these issues. I can certainly say that CPS is the reality of the future. We have been talking about artificial intelligence, machine learning, deep learning, IoT, nanotechnology, 5G, 6G, next is 7G. 7G will be in place by 2030. That's what people predict. What is 7G? Internet will be everywhere and at any time, always. That's what they. So that means we cannot come out of these things. So if we can use all these technologies and connect to the physical system, then that is nothing but the cyber physical system. One of the simplest example is a robotic surgery. In medical field, if you take robotic surgery, that's the simplest example of the cyber physical. As was said by the speaker, driverless cars, drones, and these have wide range of applications. Now, for students like you, I advise you to look at your campus, identify certain problems or areas of interest, work on those things so that there is some amount of contribution, happiness for you that you have contributed something where others are using it. So I advise you to look at small problems within the campus, wherever you happen to study, or within your locality. Try to give some solution, apply all the learning that you have from this workshop, come out with a system, and that will be very much appreciated. Now, when you talk about all these technologies will work together and then come out with a new technology that will also come up a little later. So we should be prepared for such things. The other one is we have been talking about smart cities. After a few years, we will have smart villages, smart panchayat, and everything is going to be smart. So this is an area which will be of very useful to every citizen, and we'll be in a position to leverage the technology for a better humankind. So with these words, I congratulate the organizers, mainly from the IEEE India section, again from our own student branch, for organizing this program. I certainly believe that these 2 days of your experience will be an eye-opener in many domains which you are not explored in. Thank you so much.
Thank you, sir. I would like to request Dr. T.V. Gopal, sir, Dean, College of Engineering and Technology, SRM Institute of Science and Technology, to deliver the felicitation address.
Chief guest of today's function, Honorable Vice Chancellor Dr. C. Muthamichelvan, Dr. K.R. Suresh Nair, Chair, IEEE India Council, Dr. D. Devaraj, Vice Chair, IEEE India Council Educational Activities, and my other colleagues on and off the dais, and my student friends. First of all, I would like to thank IEEE, though the Vice Chancellor has already thanked. On behalf of College of Engineering and Technology, I would like to thank IEEE India section for consenting to SRM being a host for a capacity building workshop on cyber physical systems, modeling, simulation, and analysis. It's indeed an honor for SRM, sir, to play host to this event, and we look forward to more such events to be hosted at SRM. I understand that there were 342 registrations, and close to 74% of the registered participants are outside of SRM. Out of the total, majority are students, academicians, and research scholars, with 8 participants from industry. Probably we need to look for more industry participation in future. This is a good progress from where we started in 2017. I think the IEEE SRM student branch was officially registered under Madras section in 2017, and in 2019 we had around 100 student participants during the IEEE Student Congress held at SRM. I think from there 100 we have moved to 342, and more such participants we expect in the future. And as already pointed out by Vice Chancellor, this IEEE should be made aware to other branch students also, not necessarily, because now there is no distinction between CSE, non-CSE, or few branches or whatever it is. And cyber physical systems is a common, IoT is a common one for all, AAML is common. So definitely you need to take efforts to spread to other branches also. And this is the first event of IEEE India Council that is happening in hybrid mode post-COVID. I'm really delighted to know that IEEE has funded students' projects for the last 3 consecutive years. And IEEE Madras section has sponsored FDPs for the year 2021 and 21-22. I must congratulate the coordinators, Dr. Sangeeta and Dr. Peter Roslin, and of course the other coordinators outside of SRM and volunteers of SRM to build these IEEE activities at SRM over the years, which benefits students and faculty members of SRM. I wish the 2-day workshop all success and hope that there will be many takeaways by the participants during the 2-day long session. Thank you so much.
Thank you, sir. Now I request Dr. C. Muthamichelvan, sir, VC SRM and IST, to honor Dr. K.R. Suresh Nair, Chair, IEEE India Council. Thank you, sir. I would like to request Dr. D. Devaraj, Vice Chair, IEEE India Council, Educational Activities, to honor Dr. C. Muthamichelvan, sir. Thank you, sir. I would like to request Dr. D. Devaraj, sir, to honor TV Gopal, sir, Dean, College of Engineering and Technology, SRM IST. Thank you very much, sir. Now I'd like to request Dr. J. Preeta Roslin, volunteer IEEE India Council, to say a few words about the event.
Morning, one and all present here. I'm happy to announce the details of IEEE Art and Education Activities Funded Capacity Building Workshop on the Cyber Physical System Modeling, Simulation and Analysis during June 3rd and 4th, 2022. This event is jointly organized by IEEE India Council, IEEE SRM Student Branch, IEEE Pune Section, IEEE Hyderabad Section, and Women in Engineering IEEE Madras Section. The number of registered participants for this workshop is 344, in which 111 are in physical mode and 233 in online mode. The two-day workshop is mainly focused for cyber-physical systems that are capable of making decisions and operating independently. The cyber-physical system is a cognitive system able to learn from the environment, from the human, and from itself to make decisions in real time, but the humans remain an integral part of the system's decision-making process. The technical sessions will be handled by 4 academicians, 6 industry experts, and 2 scientists. The first day of the program starts with Understanding Cyber-Physical Systems by Dr. N. Shivakumaran, Professor NIT Trichy. Second session on Sensors and Actuators for CPS by Mr. Prakash, Associate Manager, EduTech, Chennai. Third session on Communication Technologies for CPS by Dr. S. Bose, Professor, Department of CSE, Anna University, Chennai. The fourth session will be handled on Simulation of CPS using MATLAB and Simulate Environment by Dr. Devanand Singh Theo, Technical Education Evangelist, MathWorks, India. The fifth session is on Arduino and Raspberry Pi-based system development by Mr. Vasant Kumar, Assistant Professor, Savita Engineering College. Dr. Gaurav Purohit, Senior Scientist, Societal Electronics Group, CSIR CD Pilani on Intelligent Data Analytics for Air Quality Monitoring. The second day of the program starts with Embedded Processors for CPS by Mr. Amit Kumar, Software Engineer, NVIDIA, Bangalore. The second session on Design Aspects of CPS by Dr. Potre, Senior Scientist, Societal Electronic Groups, CSIR CD Pilani. The third session on Smart Manufacturing Systems by Mr. Ramachandran, Principal Consultant, Infosys, followed by Smart Grid by Dr. Nyala Das, Professor, Department of EEE Pondicherry Engineering College. Fifth session is on Autonomous Vehicles by Mr. Sushant, Senior Application Engineer, Dynafusion, Bangalore. The last session is Hardware in the Loop Simulation by Mr. Sivakumar, OpenRT, Bangalore. The valedictory session will be presided by Dr. Hosman Tiragar, Director Academics, Anna University, Chennai. Every achievement in technology needs some motivation. Let this event be a motivational one to all the participants to do your innovative ideas. Happy to be with you in this great learning platform. Thank you.
Thank you, ma'am. Now I request Dr. M. Sangeeta, IEEE SRM Student Branch Counselor, to deliver the vote of thanks.
Honorable Chief Guest, present excellencies, faculty members, students, research scholars, good morning to one and all present here. So it's a great pleasure to express my gratitude on this occasion. It's a special day, in fact, for SRM IST and IEEE Student Branch for hosting this flagship event of IEEE India Council, that is IEEE Region 10 Educational Activities Funded Capacity Building Workshop on Cyber Physical Systems, Modeling and Simulation. As Devraj sir said and Preeta ma'am said, we have more than 350 representatives participating in this workshop, both physically and in virtual mode, and more than 100 colleges, including IIT Delhi, IIT Patna. We have participants sitting over here. Thank you for coming all the way to visit our campus to attend the workshop physically. And coming to this vote of thanks, I express my heartfelt thanks to our Vice Chancellor, sir, for always supporting us. Any initiative you come up with a proposal and meet sir for guidance and approval. Sir is spontaneous in approving the same and give all kind of support. Thank you very much, sir. You are the pillar of strength for all the faculty members as well as for the SRM group of institutions. And we are grateful to IEEE India Council Chair, Dr. Suresh Nair, sir, and Vice Chair, Dr. Devraj, sir, for always considering SRM as the first choice for conducting the event and conducting the same. This is the second chance Dr. Devrak sir has given for us. Thank you so much. And I would like to thank another pillar of support, Dr. P.V. Gopal sir, College of Engineering and Technology. He is the Dean of College of Engineering and Technology, SRMIST, for his able guidance and encouragement in all our efforts. So sir was like a guide for us in guiding right from the way how the event has to be organized and how the things has to be taken forward at the higher level. Sir has been a pillar of support for us. And special thanks to our HOD, Dr. Shanti Prince, head of the Department of ECE, for some health reasons she is not able to come today, but she is attending virtually. And Dr. Vijay Kumar sir, HOD Triply, and both these HODs were always been the moral support and extended their fullest support in rendering the research scholars for participating and for providing any kind of support for the smooth conduct of this event. Thanks, sir. And last but the most important, thanks to the helping hands, the IEEE student branch volunteers, faculty coordinators, the organizing team, without whom this event would not have been possible. So thank you very much once again. Thank you all.
Thank you, ma'am. I request all the participants to join for a group photo. Participants can come forward. Participants, faculty members.
Please make it fast. Participants, please come. All please. Yeah.
Hello, please go on to the stage and set it. This way. Please go on to the stage. No. Help them. Everyone. Yeah.
Please, all come.
I want to check. Every person.
Internal participants also please join with us.
Participants from SRM also please come and join.
Excuse me, the online participants, kindly switch on your camera. Can you hear me? Can you hear me? The online participants, can you please switch on your camera?
Like I should also go and take care of
Online participants, kindly please switch on your camera.
banner is visible. See that
Yeah, thank you. Okay. உன் number எழுதிருங்க. ஒண்ணும் பிரச்சனை இல்லை. கண்டிப்பா. Yeah, thank you. Participants, kindly please switch off your camera. Thank you. Participants, this is audio check. Can you hear me? I think both shop sir responding me. Is this audible, sir?
But
Online participants, kindly switch on your camera, please.
there will be a conflict, so we have to resolve that. We won't create a problem.
So online participants, once again, please switch on your camera.
Okay, so there is the ERP, there is the portability insight, and in the settings we have added this. Hey, Hari. Okay, so for you,
Select speaker. Okay. വേണം തുടങ്ങുമ്പോ പോരെ Organic. What does that mean? തുടങ്ങുമ്പോ പോരെ പലരും ചെയ്തു നമ്മൾ കേട്ടു Where is my Kannada? Wait,
नहीं उस हिसाब से तो सही, मतलब ऐसा लग रहा है चेहरा थोड़ा सा, कभी तो एकदम खिला हुआ लगता है, कभी वैसा लगता है।
That is excavator.
Proposal writing for multiple domains like hardware in the loop, cyber physical system, industrial 4.0, advanced driver assistance system, machine learning, deep learning, etc. His previous experience includes Senior Application Engineering of PTOT, Chennai, Certified LabVIEW Associate Developer, and Hardware Specialist on NI platform. Welcome you, sir.
start? I mean, this is it enough? Okay. So sorry for the delay. Yeah. Do we have any idea about CPS? What is happening for next 48 minutes? Any idea? 2 years back, I don't not even not aware of this system. So I think it's a stop for you. Yeah, maximum of you from the engineering department, I think so. So you people from EC, computer science, this department. Maybe after a few years, we don't have these types of classifications. That's what the secret is. So basically, cyber and the physical. So previously, what we are doing is mechanical, electrical, to be like that. We have various classifications, but now we are in that new era. After 21st century, we jumped into the new technologies like the technologies like artificial intelligence, mixed reality, like AR, VR. These are all the key technologies nowadays, and still we don't have any specific department for the AI. From this year also, we have the drone technology. So this is what the technology is evolving. So before starting into the cyber physical system, we can start from the history. What is the history? Okay, I'm not going to talk about theory or the years like the history session. It's not like that. This is just for your knowledge. So basically, this is not for the new things. Already started to evolve from 18th century. If you go to the so if you start that industrial revolution, so we have 4 different revolutions here. So it's like industrial 1.0, 2.0, 3.0, 4.0. So first, up to 18th century, we don't have any automation, any machines. There is no power supply. So what we need to do is the handmade products are there. Even we don't have any mass productions now, right? So manually we need to create chairs, tables. We need to create all these things. On the day we are manufacturing the wheels, cart. These are all the man-made things. Up to 18th century. After that, late 18th century, we have the new technology. We can't say it's a technology. It's a power, the water steam power. Using the water steam power with mechanical design like gears and the fulcrum, all these things, they made the first revolution. That is what the industry 1.0. So basically, the power is water and steam. Using these things, we jump into the new production. Then after this happens in the late 18th century, then people start to use these types of machines. The first one we handmade to the technology-based solutions. Basically, we have the electricity. Nowadays, we are using the electricity same. It is around the 1830s. So that is what the second revolution. That is what the technological revolution for the industry. So that is what that's called the industry revolution 2.0. So here, what we converted the mechanical to the electrical part, then it will become the mass production. So then we know that the electricity and the mechanical design evolved. It's actually started in the Europe and the Asian countries, and basically the American Europe by 1830 and 1840s. After that, we started to spread all over the world. Then finally we jump into the automation. So up to this, we have the mechanical designs to do like here we example to run the conveyor. We have the electricity to paint we have the paintings. Now it jump to automation. So that is what
Hello.
the electricity plus automation. Basically, it started with the IT. it's happening in 1970s. This is what the industry 3.0. So the year 1970.
slide which I have shared, the Google
The years may be approximately. So this is what happened in industry 3.0. Here, what is the problem is still these machines are dependent on the humans. Up to 1970s, the machines are dependent. The decisions happen only by the humans. Then after that, what will happen in area? So this is what currently we are in industry 4.0. So can you guess what will be the next evolvement from 3.0 to 4.0? Can you guess? Sorry? Elimination of humans. Yeah, maybe partially, 50%. So we jump into the intelligent systems. So independent machines. So that's what in industry 4.0. And also we have the interconnected devices. In industry 4.0, the devices can communicate to each other. So for example, if you take the overall industry, the every edge node, for example, assembly line, manufacturing, database, every devices can connect to each other. So they can talk to each other. That is what everything is connected to everything. Is the key point for the cyber physical system. And here we, from the word itself, you can understand physical and cyber. So if you take, for example, previously shown that the image for that conveyor things, right? In the conveyor, no, is there any problem with the transaction line and all these things? And in the paint automatic manipulators, the painting the robot that know whether the conveyor is working properly or not. Similarly, every data is connected into the common database, and there we have some intelligence system to identify whether everything is going properly or not. So this is what the industry 4.0, basically cyber physical system. And this is happened in the 21st century. Still we are in the same technology. So what will happen after 30 years? So do you have any idea what will be the next 5 years? What is the next 20, next 30? What will be the next technology? Still we are in the cyber physical system. We just started this cyber physical system. Still we don't have any department like cyber physical system. Few colleges have in this department. Basically the concepts like both they should know the mechanical, the electrical, electronics, and also computing. They should aware of all these things. So basically, what is that? We can say brainstorming. The same concept will start to begin in this CPS department. Now, to the next. This is what happening in the 4.0. Two things happens from the humans, two things happen in the systems, and here you can see every device is connected to each other. And in this technology, what we are using, the Internet of Things, augmented reality, what is the big data analytics. These are the key terms. And last few years, around 5 to 3 years, we started to use 3D designs also. Now it's happening using the plastics, right? Some form of plastics for the 3D design. Maybe next 30 years, they can manufacture the basic, what is it, human hands, legs, and the human body. They can print our organs. So that is what that may be happening after 30. These are the predictions. We can't say whether what will happen or not. So this is what the 4.0. And what all the technologies depends on this 4.0 is say IoT, IIoT, augmented reality like the VR, AR, and AR, then 3D design, robotics, what is it? Big data analytics. Basically, we can say cloud computing. In the cloud computing, for the intelligent computing, we have the AI. Under that, we have the these things, right? So this is the thing. If you jump to that architecture, so still I hope you have some idea about CPS. So we jump into the architecture. Up to this, any queries, you can raise your hand and ask. Up to this, this is what the history from 0 to 4. and 5 maybe within 5 to 30 years we have self-driving car, what is it, taxi, normal self-driving taxi, or we can say taxi drones, mixed reality. These are all the key technologies. With that, you should be aware of robotics, intelligence system. This is what you need to focus for the next 2 years if you want to sustain, or if you want to, with the technology students, you need to focus the intelligence system and robotics. You should combine both things. This is not separated things. You should learn both robotics and intelligence systems, artificial intelligence. Any doubt? Is it boring? Yeah. So next we jump to the architecture. So this is what I have previously mentioned. The devices should know what is happening all over that area. Each and every node should aware of aware of the remaining system. What is happening in the A system, what is happening in the B system. So every device is connected to each other and they work as a synchronous system. Even the data, you can see the data is simultaneously sending to the cloud. Okay. Yeah. Now, if you check the CPS, it have 3 different categories. One is we can easily memorize 3C. 3C. Okay. So C is like controls, communication, and the computation. So here, what is controls? The controls means nothing. For example, if we take this simple conveyor, I should control the conveyor in the same speed, even with or without load. So that's what we require the control system. A standalone control system should be there. Okay, so for that you require the control system. Okay. Next, what is communication? Previously mentioned, everything connected to everything. So here how the communication is happening. Here also we have the communication like 5G. 5G is one of the technology, but it's not only the 5G. Okay. The 5G is using nearby transmission, like car-to-car communication. In the self-driving car, for the overtaking or with the turnings, we should know what we are going to happen. So the data we need to transfer from current car to the next car. So for this case, we can use the 5G. Then from the car to cloud. Okay. So what will be the next third corner signal? I should know what is happening there. So for that, we require the cloud computing. Okay. So basically, we have 2 different communication. One is RF, another one is IoT. Basically, it's called the IoT. The IoT means the basic things. Here, the general terms, what we are using is Internet of Things. In your mobile, you have the Google Drive, cloud. Nowadays, everyone aware of the cloud, right? The same thing for the industries. They have the Industrial Internet of Things, IIoT. Do you have any idea about IIoT? What is the difference between the IoT and IIoT? Any guess? These are the common things. IIoT. I'm not talking about the full form of IIoT, Industrial Internet of Things. That we know that. So, what is the difference between IoT and IIoT? The personal cloud computing, you are using our own data set, files, documents, images, all these things. But in the industry, we need to transfer the data of sensors. So that is what the sensors and the actuators data can communicate with the cloud. So this is what the difference. Okay, if you go to the home automation. Home automation, we can say it is industrial things, it is a self thing, but it's also similar to the IoT. So here we require what is the room temperature, what is the room pressure, what is the room intensity, light intensity, all these things. The similar way, we need to collect the multiple data, the most data from the sensors to the actuator and industry. Then we need to send the overall data to the cloud. So this is what the industrial Internet of Things. Okay. So that is what comes under the communication. Then finally, computing, and maximum of you from IC, I think so. So you are aware of the intelligence systems like static data analytics. This all comes under the computing process. Here, previously we used only the mathematics. So what is the difference between the general static and the data analysis algorithm versus AI algorithm. Last 100 years, we are using the same mass. Now, currently, why we require this AI-enabled data analysis of these types of analysis? Why do we require? Any guess? Sorry? Yeah, well, self-learning implement. So basically, the key things is if you talk about the image, for example, I require the image. In the image, for example, whether the laptop keyboard is manufactured properly or not. So for that, I need to do in traditional method is manually we need to check it. After that, using the image processing, we have done. But for this case, analysis to do the analysis for the keyboard, we require the separate algorithm, image processing algorithm. Similarly, to monitor the desktop overall screen, I need to check whether the screen is manufactured properly or not. So for that, we require another type of image processing algorithm. Okay, so for this case, individual process require individual algorithm. Mathematically, we need to do the different image processing algorithms. Okay, but if you jump into that AI, so here what is happening for both keyboard or desktop or anything, I need to do whether it's good or bad. So we can use only one algorithm like regression, linear regression, logistic regression. We can use the simple algorithm. With the trained model, I can do whatever I require. So for example, I need to check whether it's a tripod or not. Directly I can use the linear regression. Okay, here I need to detect whether it's a human or not. Directly I can use the linear regression. So here we don't need to use multiple algorithms. So that's why we require the artificial intelligence for the statistics and analysis. Got it? Is it clear? Yeah. Now we move to the architecture. Basically, this is what happening under the controls CPS. But here we have the general architecture. Yeah, this is what the previously mentioned. What are the technologies depend on the cyber physical system? Already I mentioned AI, IoT, big data, and few more user interface and flexibility. For a few years, we can see we are using the tablets, right? Next 3 years, we are going to use VR or VR businesses, right? So that is what are the human machine interface for the design, study, for the analysis. The human machine interface will be replaced with the AR, VR, and mixed reality. Yeah, this is what the user interface for the CPS. Not now, maybe within 3 years, 5 years, it will happen. I don't know whether it's visible to you. So here we have various categories there. If you talk about the CPS, we should have a feedback system, cyber security, and real-time RT, networking, and also what are the applications. We know that communication, consumer energy, infrastructure, healthcare, manufacturing, military applications. These are the various applications. It's not only for the IT sector. Maximum of you thinking about the technology is not, it's only for the IT. Okay, even for example, what is the role of IT in the self-driving car? The general application. If you take the self-driving car, what is the roles and responsibilities for the IT? Okay. You are saying something, but it's not audible for me. But anyway, okay, no problem. Don't waste your energy. I will try to give my points. You just check it whether you are correct or not. Sorry. So here, the roles is they are also providing the technology. Okay, they're just providing the solutions. For example, if you want to drive the autonomous car, the algorithm to drive on the track, we require some form of algorithms, right? If you talk about the CNN convolutional network, we need to drive the algorithm. So the role for that algorithm development, the IT sectors providing the solution for the self-driving car, basically the transportation application. Like that, we have different types of applications. So the CPS is not only for the IT, it is for multiple applications. That is what I need to focus. So here, if you want to do all these things, basic thing, it's robotics, and artificial intelligence. These two is combined, these two form will become all this application. Okay. Yeah, next. Next. Here I'm representing the national instruments. Currently, I'm getting some form of hardware like in my view. I will show the hardware to you. So you can see the hardware. Yeah. This session is basically from the NI, so I'm also having one student hardware. It is a embedded hardware called a MyRio. Okay, it's a pocket size and bone size and weight we can carry it in pocket. So like that, NI providing the multiple solutions for covering overall CPU systems for communication, computing, and controls. For the communication, they are providing the 5G technologies. For the computing, they have the edge node sensors and the actuators. And for the programming all these things, we have the LabVIEW platform. LabVIEW is a graphical program, so you can design your own program with the graphical icons. That is what the LabVIEW. I think you have some knowledge of LabVIEW. So we jump into the architecture. So if you talk about the layers, in architecture we have multiple layers, right? I hope a few people from CS. Can you tell me what are the layers available in CS for the IoT? What are the layers of that? Yeah, what are the layers? So first one, we can go from the bottom to top, or you want top to bottom. What do you want? Okay, we need to climb, right? So we just move from the bottom to top. So first, it's called the edge node. Basically, we can take one example. The conveyor is the best example for me. We can visualize the images. So in the conveyor, it will detect the bottle. So for that, we require the sensor. Okay. Then to drive the motor, we require the to drive the conveyor, we require the motor. And to control these two things, we require the controller. So these are all the edge node, edge layer. Okay. Then after that, what we require? Don't see the screen. It's for your overall picture. It's not for that layer by layer. It's not in the layer by layer format. What is the second layer? After that, after control the part, what is the next step? We need to log the data, correct? We need to log, we need to do some analysis of all these things. So we need to transfer the data to the database. Then we can store the data. We can use cloud or we can use fog. Okay. So fog is the second layer and the cloud is the third layer. Maybe you know the cloud and the fog. Cloud means from the private sector, we can buy some solution for the cloud. We can buy it from Amazon or IBM. These are the private cloud solution providers. We can buy it. This is the cloud. In between, in the manufacturing industry, they can create their own cloud, but it's not a cloud. We can say it's a fog. So in this fog, what is happening? So directly we will save all the data in my system. In the industry, I have some form of servers. My main server is there. I will log all the data in the local server. Basically, the local server. That is what the fog. Okay. So for example, here to run the big conveyor like a Coke company, we have n numbers of data. Okay. Millions of data will be there. Okay. So to store all the millions of data in the cloud, in the private cloud, we need to pay for that. Okay. So there is a storage problem will be there if you buy it from the private cloud. So for that, instead of sending all millions of data to the cloud, I just introduce one new layer, that is what the local server. What are the required data? I can shortlist, I can send the remaining data to the cloud. So this process will happen in the fog. I will transfer all millions of data to the local server. I will store it, I will process, and the required kilo samples or only the 1,000 samples we need to store it in the cloud. So for that, I will transfer only 1K samples to the cloud. So in this case, 1 million to 1K is a huge difference. Okay, 1 million is just for your knowledge. It's not 1 million, it's more than that. Okay, so to avoid the storage and to pay more amount, we can use this middle layer. Okay. So this is what I have given as a image here. Uh, the last layer is sensors, actuator, and the controller. This data can be sent it to the local server. From the local server, we can send it to the cloud. This is one method. Okay. And the second method, directly our controller can transfer the data to the cloud. I hope you have the Raspberry Pi and the Arduino. You are just sending the data directly to the cloud, right? This is the second method. Okay. With the same platform, we can do both from device to device, device to fog, fog to cloud, device to cloud. Okay. So now we can see we map the device to device communication. So everything should know what is happening in the remaining things. So here this is what the overall architecture. Now I have planned for the demo, but I thought it's like a classroom, just a few people sitting in the classroom in front of the projector. So I just carry my laptop with all the program and all these things. But right now the presentation is over. I just showed a few examples to you. Okay, I'm having only one hardware. So right now, so it's not possible to give doing the program all these things. So directly I will jump into the algorithm level. I would like to introduce the LabVIEW software. I just open the LabVIEW software. Okay. So before moving to the LabVIEW, so you know what is LabVIEW and who is NI? LabVIEW. Okay, LabVIEW is another graphical programming language. It's a platform. It's not for that, not only for the CS or it is a general platform. So each and every part of the engineering things we can do it in the LabVIEW. Spelling is LABVIEW. Laboratory Virtual Instrument Engineering Workbench. Basically, the National Instruments, they manufacture multiple sensors and actuators and the controllers, and also we are using the LabVIEW software. Basically, LabVIEW is NI software. So I hope you have the mobile phones. Just browse it, ni.com.
Yeah, of course.
ni.com. Can you get it? Yeah. So from that you can see the LabVIEW platform.
Yes.
Yeah. So with this platform, LabVIEW is one of the platform. I'm not forced you to use a LabVIEW for the CPS. Okay, I'm just showing LabVIEW is one of the platform. You can use any platform. I'm not restricted to the technologies. So what are the things we need to focus? That is what we need to see here. Okay, we just move to the one by one. If you talk about the controls. So if you require, you can note down it. If you want to do the controls, what are all the things you need to focus? So first thing, in the cyber physical system, one of the three C, first is controls. From the sensors and the actuator, we need to do the controls. So first part, under the controls, the modeling. It's not about the catwalk in the stage. Okay, I'm talking about modeling, mathematical modeling. It's not about the general modeling. It's a mathematical modeling under the controls. So do you know why we require this mathematical modeling? Okay, for example, I need to jump from here to the bottom to the floor. So So what will happen to my knee? It will break, right? To test this thing, I no need to jump it from the floor. Okay, I do the mathematical modeling of the humans, the physics, dynamics, all these things. Similarly, if you want to test the rocket, you no need to directly launch the rocket. First, we need to convert as a mass. From the mass, we can design all our controls. So basically, it's nothing mass, physical domain to physical dimension to the mathematical representation. Maths, only the maths equation. Here we can see physics, dynamics, kinematics, all comes under this mathematical modeling. It's not only for the humans, it's like for the drone, rocket, a car, everything. Mathematical modeling. So what is next? After mathematical modeling, what we need to do? Is just a mass format. Now we need to see the response. Okay. So here from I need to take care of my overall body and overall weight, kg, and what is the gravity. I need to measure all these things. With that, I need to measure the acceleration, and I need to check what is my knee stability and knee power. With that, we can find what is the break point of my knee. Okay, this is just a mass. Okay, now I need to simulate it from 10 to 20 meter. From 10 meter to floor. What will happen from 20 to floor? What will happen from 30 to floor? What will happen? This is all we need to see in terms of response, in terms of time domain, in terms of frequency domain. So this is what is the simulation. From the mathematical modeling, we can give the input. So for example, here I have the tripod. I will keep the tripod. So how long it will just fly. So similarly, we have the mass equation to the response in terms of time domain and the frequency domain. This is what is simulation. This is just basic example. If you talk about the conveyor, what will happen for the motor? If I give the step response, what is the response time? What is the settling time for the motor? Then, if I give the AC signal to the motor, what is the response? What is the settling time? All these things I should hour at the motor. Then only we can control the motor. So for example, take the drone. First, you should know what is more drone equation, and from that you get the forward input in with that we can understand the response. Then the third one the control design. In this layer we do all our controllers like PID controllers, feedback controller, and more controller. We can do the third thing, control design. Then final one is validation. Deployment in the real system, and we can validate. This is what the 4 layer. Okay, the control system is over, I think so. Up to this, any doubt? Up to this, I just give 2 minutes just to go to this. I will open few examples to you so you can see what is happening in modeling, control design, simulation, all these things. We will give in the demo. So right now I directly jump into the lab view environment. We have 2 different windows. One is for the user interface, another one is the programming window. Like your C++, you have just writing the script in one window and to get the input and output in another window. Like that, we have the lab view 2 windows. So right now, this is one method. Lab is one of the solution. So you can do in each and every platform. So here, what is the advantage? I just open the programming part. This is a user interface. I need to open the programming window. So here, what is happening? I try to give some examples to you. In these things, you can see various blocks like summation, state space, transfer function. Here, few statistics, and finally the mathematical model. Yeah, in the middle one is the mathematical model. So here, these are all the blocks. If you talk about the math script, you need to type all the script. Okay, right? After that, you can give the input and output in the form of script. In the lab view, we have the icon. For the drone, you can call the mathematical model of the drone as a block, and you can give what are the values. For example, KP, KD means you can directly call the blocks. Here you can see summation, gain value, all these things. You can directly give the input and output. We can test it. This is what the difference between the traditional approach and the lab view graphical program. Now I just show the front and run the program. So here we have the drone. Right now, I need to design the drone controller. Okay, what you are doing now? Maximum of you having some form of drone, but there is a problem. The drones already have the controllers. You can directly buy. You can configure whether it's a 4 motor or 6 motor or 8 motor. You need to configure. After that, you can directly fly. There is a no learning from that type of drones. Okay, we need to do our own controller. Okay, then only we can develop it for the stage. So here I want to control my drone. So basically I get the mathematical model. After that I'm going to give the input and output here. So input, you can see what is the altitude and what is the longitude. I need to control. Just move a little bit. So for example, now I'm just changing the altitude. Now I need to control the longitude. So I'm just moving forward and backward in the workspace. X and Y axis. Okay. Now, what will happen if I give the noises to my drone? Whether my controller is stable or not? I need to check it. We have the noise level. So, manually, I'm going to give some noises. How we are using the wind turbine, or in the fan, we are using this form of physical noises, right? The same way, we can give the mathematical noises to the drone. Now you can see the drone is not, it's trying to attain the stable state. Okay, this is how you need to validate. The final stage I mentioned, validate, right? So this is what happening in the validate. Here you need to validate because you can't do the validation in the physical system. In the real drone, you can't give the wind, all these things. Directly you can give. So here we are giving the noises manually, and we are trying to check whether the system is stable or not. Okay, this is what comes under the controls part. Okay, now we'll jump into the communication part. So what are the communication part? What we need to focus? Okay, one thing is RF communication. Right now we don't have any hardware or any software simulation. Okay, basically from all these things we can do it with this country. With that we have the USRP. Maybe few people from the communication part. If you have any queries under the communication, you can approach me after this meeting. Right now I just move into the IoT, Internet of Things. If you focus the Internet of Things, cloud communication. First we just see the cloud communication. After that I will move to the remaining device to device communication, how it's happening, device to fog, how it's happening. Right now I will give the notes. You can note down the notes. Okay. So for the IoT, maximum view comes from the CS. So you are aware of HTTP. Okay. HTTP protocol and MQTT, something this form of protocols is there. So basically, the maximum IoT platform support HTTP. We can do HTTP protocol in the lab. So this is for the device to cloud computing, device to cloud communication. This is what happening there. For the cloud computing, we need to buy the AWS solutions. For example, Amazon Web Service is one of the solution. Okay, that in the cloud you need to do the statistics analysis. All these things will happen. That is for the cloud computing. If you move to that device to device communication, for example, in the same room, from this hardware to the another MyView hardware. So for example, the device to device. So what is a suitable protocols, or what is a suitable communication solution for that? Any guess? It also comes under the networks. So you know that TCP and the UDP, transmission control protocol, and the user data plan protocols. You just note down these things. These are all the device to device communication. To get a reliable data, we require the TCP or UDP. This is how happening in the industry. We can transfer the data from device to device. So what is the difference between the TCP and UDP means? TCP, it's like a interconnected. So every time master and slave is connected very strongly. Before sending the data, master will check it whether the client is ready or not, the server is ready or not. After that, it will transmit the data. Similarly, the server should communicate whether it will receive the data or not. So it is a very strong communication. If there is any problem in the communication, it won't happen. The communication won't happen. This is one type of device to device communication. It's like a single point to point communication. If you talk about the multicast or broadcast, like your video streaming, image, voice streaming, this all comes under the wide broadcast. For this case, you can go with the UDP. So master and slave no need to communicate each other. Master will transmit the data continuously. The server is there means it will acquire the data. If there is no server, master don't consider the things. It directly continuously just transmit the data. That is what is the UDP. Here also I have some example, but I don't have the best example. It's just for the basic thing. So this is what previously I mentioned. If we talk about the communication, we have TCP, UDP, and the serial communication, and also HTTP. Okay. Now you should aware of that the communication part. Okay. So for example, I need to communicate my MATLAB to the Python. So for example, artificial intelligence, you are good in the Python script for the intelligence system. Okay. We have the MATLAB for the simulation. So how we can transfer the data from AI to the MATLAB? This is one of the real-time examples. So I don't know whether you are good in MATLAB or the AI, but you're good in Python AI, correct? So that you have the library you can call it. But in the simulation, the MATLAB is the best example, best platform. So now, right now, I need to combine both Python and the MATLAB. So how it's happening? Okay, so for that, again, we need to use these types of protocols. Here, for example, you require the reliable communication means you can go with the TCP. So from the TCP, we can write the Python script. You need to enter what is the IP address of my MATLAB system, what is the port. Similarly, from the MATLAB, what is the receiver, what is the transmitter IP address, what is the port. So if you run both examples simultaneously, you can transmit the data from Python to the MATLAB. It's not only the Python to the MATLAB, any platform to anything. Okay, Python to LabVIEW, LabVIEW to Python, LabVIEW to MATLAB, MATLAB to C++, JavaScript. So anything is happening using these types of protocol. The only thing is you should connect it in the same network. Okay, that is what the network protocol. This is one method, and the next method is cloud computing. Okay, so here remotely Python is available in one system. It is available remotely in some location in somewhere in the world, and MATLAB is available in front of us. So this types of data communication we require the cloud to cloud. Okay, so for that you need to use the HTTP protocol. You need to give the URL. Okay, for the MATLAB, we have the ThinkSpeak. For the IBM, we have the IBM Cloud. For the Google, we have the Firebase. These are the various cloud platforms. So Firebase is a free platform, so you can directly use it. So from the Python or from the MATLAB or from the LabVIEW, you can transmit and receive the data to the Firebase. If you check the ThinkSpeak, it has some delay. From my understanding, it have a delay from 6 to 7 minutes delay will be there. If you see the Firebase, it have very low delay. We can't see the delay. If you see the Firebase, So I'm logged in with my account. I already done some example. So I just try to send this MyRio data, this hardware data to the cloud. From the cloud, I can get it to the mobile phone. So this is what happened in my program. So here you require the real-time database. In the Firebase, you can create this account. It's free of cost. You can create it. And from here, you need to get the URL. First, I will show the Firebase user interface. So you can see the URL. Okay, for the HTTP, you need to give the URL. From the URL only, you can transmit the data and you can receive it. So in this Firebase, you can directly control the data from this window itself. You can see the x-axis is just my accelerometer data. It have the inbuilt accelerometer data. Last time I just transmit this accelerometer data to the cloud. That is what you can see in the x-axis. So here you can control the data from the cloud or device to data. It can be transferred. So here I just copy my link and you can directly open into the program. So this is one of the program for transmitting and receiving the program using LabVIEW. In the Python MATLAB, you can directly enter the URL and you can directly enter the data. So basic thing is you need to configure, you need to write or read and close. This is what the program here. You can see the 3 layers. So first part. So I will show the, you can see the block diagram there. So the first green color is open handle. In LabVIEW, we have the 3 layers. First one, configure the cloud. Second part, read or write. For example, now we are going to now I'm going to write the data. Hello world, like that. I'm going to write the data. Okay, so for that you can give the write. For example, if you want to get the data means you can go to the read. Then finally close. This is what the 3 icons required in the LabVIEW. But I'm not aware of the MATLAB. So Python also you have some basic script. What is the server, IP address, what is the URL, what is the data. You need to convert the data format to the JSON format. Basically, the string, numeric or any data should convert into the JSON format to send it the data to the HTTP protocol. The basic conversion is happening in the LabVIEW also. It's convert the data to the cloud. Now I'm just running the data. I'm just randomly send some number from the LabVIEW and hello message to the cloud. And now you can see the cloud receiving the random number and the cloud. This is one of the examples for the cloud computing. Sorry, cloud communication from the LabVIEW to the cloud. Same way we can transmit from Raspberry Pi, Arduino, LabVIEW, MyView, DAC, any hardware to the cloud. Not only with the LabVIEW, also MATLAB, Python, everything is happening. This is what is the communication for the cloud. Then finally, computing, I already mentioned, you can do both edge node computing as well as cloud computing. Edge node means you can directly deploy your AI in your remote system, in your own PC or laptop to do the statistics. In Amazon, they are providing the cloud computing. They are having the AI in the cloud itself. So you can directly deploy the image. They have the model. You can directly select the algorithm, which model you need to require. So also the models that I checked the AWS, they are also providing the models. For example, data set. I require the road image. So it's not possible to get 1,000 images by the humans, right? So for that, the database is there from the Amazon. So directly you can get the database for the road, and you can train your model with the cloud solutions. So this is what the CPS. So I just started from the history, then layers. After that, we jumped into the 3-part communication, computing, and controls. I started with the controls, under the controls, modeling, simulation, control design, and the validation. Then we jumped into the communication part. In the communication, I mentioned the RF and HTTP UDP protocols. In the same network, you can go with the TCP and UDP. In the different network, you can go with the HTTP. Same network is for the local area, so device to fog, device to device. For the cloud, we have the HTTP. For the service, you have the IBM or AWS. These are the paid one. The free cloud for the students is like ThinkSpeak and this Firebase. This is a free of cost. Then finally, computing also, I don't have the account for the AWS. In your free time, you just try with the AWS cloud computing. Yeah, that's all. If you have any queries, you can ask. After that, I can give. Is it okay? Shall I leave? Sure. Yeah. Bye bye. Thank you for your time.
On behalf of this event, we thank Mr. Prakash and his team for accepting our invitation to deliver the lecture today. And we have been associated with their team for a very long period. In AAA department, we have developed an NA Academy Center with their support, based on which we have developed some cyber-physical systems hardware setup also. So it's a very indeed a great event to have their team here for this event also. Now I request Dr. D. Devanand sir to felicitate our speaker, Mr. Prakash.
No, sir. Center.
Thank you, everyone.
There's a refreshment arranged for the participants behind the mini hall too. So you can have your refreshment and come back in 5 minutes. So the session will be followed by Professor N. Shivakumaran, NIT Trichy.
Suppose the students are online, they ask questions. Can you?
We can transfer the data to the back to them and I will collect it.
Okay. So online, if they ask questions, can you enable the speaker? Is it possible?
Yes, sir.
Huh?
Yes, sir.
Possible. Oh, sorry. Oh, your team. It's possible.
Yes, sir.
So next session you take care of it.
Okay, sir.
So this session itself we have informed them. We ask them to share the question on the chat box. If it is shared on the chat box, you read it out. In case if they want to ask, if you enable that speaker, it will be audible to audience who are present.
It will also project the question very.
Sure.
Yes.
Sure. Whatever is there, you just note it down. At the end, you can ask the question.
Okay, sir. We have internet connection. Yeah, yes, sir. இல்ல அது இந்த ரூம்ல பேசுற கேப்சர் பண்ணி தான் நம்ம கொஞ்சம் சவுண்டா பேசணும்னா மட்டும்தான் அது இது ரெகனைஸ் பண்ணி அங்க போகும். அது கொஞ்சம் இந்த ரூமோட எல்லாமே
Some of them are attending physically.
Okay.
Remaining 150,
Oh,
they are
okay.
online.
Okay, sir.
So you take care of
Okay,
them.
okay. Shah Shilpa? Hello? Shah Shilpa, have you mailed to my mail ID?
Yes, I have mailed it to you as well.
But I haven't received. Yeah. Now it's there.
லஞ்ச் போடுறியா?
ஆமா எனக்கு நைட் திருப்தியா இல்ல இப்ப நான் ரேடியோ எல்லாம் சாப்பிட்டோம்ல எனக்கு கலாக்க வீட்டுல இருக்கீங்களா அங்கே தூங்கு
Yes, I would like to introduce Dr.
ಅದು ಬಂದು ಫಸ್ಟ್ ನೋಡೋದ್ರಲ್ಲಿ ತಗೊಳ್ಬೇಕು ನಾನು ಮಾತಾ ಅದಕ್ಕೆ
of identification and control of non-linear chemical processes using recurrent neural networks in March 2007. This research areas includes process control, biomedical instrumentation, physiological control system, and intelligence systems. Indeed, we are happy to invite Professor N. Shivakumaran sir for this event.
Good morning, everyone. So can you able to hear me? So it's once again I did pleasure to be a part of IEEE India Council organization on cyber physical system modeling, simulation, and analysis. So in this regard, I like to thank Dr. Devraj, who is my close friend and very important academician, especially in the area of industrial automation, and he's well-renowned person, especially he's very active enough because his schedule was very rigorous enough, and he tried this happening before a month. So this was indeed a very pleasure thing because always we engaged, especially in many of our systems. We are very much engaged, especially as far as academic concerns are there. And with respect to research subject, he always takes a very interesting initiative because we have a very important CPS division at NIT system. And as far as his acceptance, I myself do not know, I may or may not be present, but I am very much happy to see a very interesting gathering, especially on a technical event. Most of the events are highly appreciable by his organizing event, especially under IEEE banner. He is very continuous and very keen person, especially with reference to the subject on state of art technology. So here, I am very much happy to be here as a part of CCPS team. Especially, this is a very interesting thing, very interesting theme of the current scenario. So when I like to talk about my presentation, because when the topic is CPS, I cannot always see on the parallel. I am seeing event organized by agriculture scenario. That is a scenario happening in agriculture where I could see some of the stalls where any innovation, especially industry 4 is there. One such industry 4 is there on the way. When I am walking down, you see a drone with spray. Okay, so you see a drone technology, one of the could be from incubation center. We could see power gen company by itself. So this is a very interesting thing. As you see, I cannot confine with my lecture.
I could very much happy to see that whether so as part of the CPS, you know very well what a CPS is, and I'm going to talk about how this integration is happening in with reference to industrial scenario. So the scenario has different options, different interpretation, but you see that above all, my thing is going to be on case studies. So what we do at NIT Tiruchirappalli is very important for everybody. And as you all are aware that what we mean by a CPS is just an automation, task action. So when it is going to be a web-based cloud, my first question is to the participants. How many of them are aware of the applied research happening in CPS? This is a very interesting thing. A computer science engineer can work on CPS, and electrical and electronics engineer, and electronics and instrumentation engineer, mechanical engineer, and an IT professional. So whomsoever, it requires an interdisciplinary research. So this is what is my experience. We cannot say that CPS is for one specific domain. So when I talk about the scenario of what agriculture scenario is what is happening, you see that we have an automation done for our farmers. So our target industry are manufacturing and automation. Next important target is our healthcare technology. And see, when I am coming out here, I have included one of the very important thing. You could see that from my presentation, I have included case studies with reference to smart grid and implantable device. But after I see the entire schedule, I also thought what we do at NIT Trichy, especially in smart city projects. See, government is taking many initiatives. Where and when you see that Make in India word is trying to hear your ears. But how far we are going to work for Make in India is going to be the real important target for the current situation. So in this, you know that this is an integration, as I said. How a manufacturing industry is going to get benefited with reference to Industry 4, and how a medical device. See, everybody nowadays in medical industry is the state of art, especially after COVID. Trying to create a database for a CPS is very important. Any hospital, you see, paperless office, digitization happening in India. You could see that the first important revolution where the entire global scenario was looking into our Indian system is Arogya Setu app. I think many of the users of Arogya Setu app knows what is the important. When I was traveling at that time, when there was a COVID, when I am traveling from India to US, I could in the airport I could realize that there are n number of forms. See, I am going to University of Connecticut. At that time they said, "Sir, you have to fill in a form for traveling to that state, especially in US, from Boston to Connecticut. You have to fill in the form." Yes, I did. After I did, when I go inside US, I could realize that network control system was persisting. Wherever I do draw a travel in my mobile phone, that was also happening in our country. It says that these are all some of the COVID affected patients. So at that time there was no vaccination, nothing. Okay, so that was the scenario. And when I returned back from the same Boston to India, our Indian government asked series of forms. Okay, so that I mentally prepared. I filled in. I could see what they asked. We have to provide because it is disease which was not tracked, which was nobody knows how the infection is going to contagious disease, how the infection is going to happen. So I could have a number of kits on my own kits saying that if a COVID patient is coming affected, I know using my kit. So everything was happening. When I could see the scenario in US, the system was totally different. Schools are running. In Indian scenario, all these schools were kept closed, whereas there you could see the scenario is changed. offline classes were very prominent at that time itself. Even when I finished at Purdue University, their classroom lectures were happening in offline mode. If a COVID patient is affected for 1 week, they will just close for 1 week and again it resumes. So that was how the international scenario was there. But in our country, you see that the networking was playing a very important role, especially in RHS app. When I do take my mobile to anywhere, they ask me to show what is happening with my database. Am I right? So that was the start of the CPS system with reference to Industry 4, where health technology played a very important role. Major hospitals, if you are a COVID affected patient, how does the database know? RHS app does the measure. Is that clear? So this is how the technology driven scenario, as I said, you see that it is hybridization. It's an international interdisciplinary hybridization, where no one can say, no, sir, I don't want a CPS. Why? Because then the same healthcare technology is extended for the agriculture scenario. When you see that technology is there, how the farmers are going to take. See, you see that the Indian growth of economy was sustainable because of the agriculture. You see that on one side, everything was kept closed. On the other side, you see Indian agriculture played a dominant role, or else you could see what the scenario happened in Sri Lanka. So that was the base for our system. One side we have launch of aerospace, we see launch of satellites are going through, launch of food commodities, healthcare technology, everything was in parallel with each other. So that was a very important scenario. We could see that Indian sustenance, for even though our population is heavy, there was no starvation of foods. So we have to appreciate the technology scenario, because I have a very interesting thing after I should have done, but I forgot, but you can get my papers on my presentation. We also developed a smart technology for 210 capacity storage, cold storage unit at NIT Tiruchirappalli. So that was very much beneficial for farmers. So I was about to see this on the farms, but I could not see such facility because excess storage. See, farmers are doing their cultivation. One side you see government is preponing the opening of the dam, that is water for Kaveri. At that time, they are not, farmers are not planned. Their control system is not planned to do anything harvest before. So it's a fixed mode of operandi, where 3 years their agriculture routines are maintained. The sustenance is fixed. Whereas in case of a CPS system, we make the system as a operandi. So that is a very important thing. This is what the CPS structure, and the CPS structure plays a very important role with reference to communication. So communication system, that is how IEEE is going to play a very important standard. In Indian scenario, you see we have so many people work on developing prototypes, but there is no standardization. Standardization is not available in our country, whereas in Europe or US, you see any screw or nut, if you are going to replace, there is a standard. So that is followed through IEEE. So such workshops only made the industrial people to get more adherence, and these adherence definitely going to help the scenario of what we are going to develop, especially for our nation. So this is a international standard. It is going to be an international standard. It's not confined to a specific technology. So any international scenario requires some standardization. So this is a very interesting scenario. What we are going to do at last, you see why it has been extended to manufacturing industry. See, at last ultimate aim is to reduce the cost. See, an automobile industry, what was the state of automobile industry before COVID? Before 20s, if you are going to a shop looking a car, you can get a car within a month, not more than a month. Am I right? If I book a car, you will get within a month. But now you see after COVID, after your registration, they are fixing everything, then only the data is sent for manufacturing. You see, because Maruti on the other side, there is a company, there is a very important company for India, which does not manufacture diesel vehicles, only petrol vehicles are manufactured. Other side, we talk about technology, CPS is going like anything. On the other side, you see that the scenarios, companies are very much bothered, worried. If we are manufacturing excess cars, who's the stakeholder to get? Because on the other side, you say that all the shops are closed, all the economy is down, who is going to pay money? On the other side, industries are ready to manufacture, excess manufacturing also is a problem. So now if you book a car, it takes 3 months time. In the entrance itself, all the automobile companies are placing that after your registration, it takes 3 months time. What is the 3 months time? Is that after your booking only, the system is hybridized to produce vehicles based on CPS. Is that right? The scenarios would totally change, and the global scenario is competitive because of the technology driven. So this is the CPS scenario. You could see that sensors and actuators are going to play a very important role. So how do you make a cost-effective sensor? Is one of the items. So today morning I read a very interesting article with reference to CPS. You see, Kaveri Hospital in Chennai started doing operation, started doing a valve replacement without surgery. Without surgery, there is a valve replacement because of the Industry 4. So you see, the technology is developing, especially in agriculture. You see, the Adayar River, especially in Chennai, is getting clean because of the drones. Drones do a very interesting job. It is a hybridization on CPS4. Other side, you see, offline to online, online to offline. Especially, I think SRM University is also facing such problem. Our threat is students. The behavior of students before COVID was different. The behavior of students after COVID was different. You see a difference in my class if I say offline class with the offline exam. There is a protest. All right? Students do protest. Students say, no, sir, we want only online exam. You have offline classes, but I want online exam. What is the scenario? The scenario itself, there is a hidden fault tolerance system sitting. I don't want to mention the fault tolerance, what is happening. There are many startups even emerging to do examination for students as startups. Many startups in Chennai or in many of the states, they have startups for writing the exam, writing their examination. So question paper is sent, answer is received by the same students, handwriting is fixed, everything is also hybridization, automation. We cannot say, no, we should not allow the technology. So faculty should be very proactive enough to set a question paper where such a startups will not answer. So the scenario is for everybody. So it is an interesting thing where the same Industry 4 is also playing. Same data is stored in the cloud. And the data is retrieved with n number of different signatures. Signatures in the sense writing style. So writing style itself is different for 60 numbers in a class. 60 different writings are done. And immediately the answer is given on before half an hour so that students can again check and upload. So this is the strategy for international scenario. So this is not only here, everywhere. So when I talk about the technology, we should be proactive enough. I need to have a very strong firewall. I need to have a very strong system. I need to have a very strong interface to establish these things. So these are all about the scenario, whatever I talked about, especially in US or CPS. Yes. So this is what the physiological system is. I said everything. Everything in the sense whether it is semi-automatic or automatic. See, everybody talks about automation. And you see, even I have to rely on my mobile phone. See, before 15 years, you see, mobile technology was diluted, saying that you see there is a microwave affecting your brain. But nowadays we cannot say, because I'm asking my kid to study the class using a Mac. I ask my kid to study everything in my mobile phone. If my Mac is not working, if my speaker is not working on my laptop, again I am giving my iPhone to talk. Is that right? So now I am giving technology to the young people. Whatever which was said no, nowadays they are all playing with Mac and mobile. So the technology is a scenario that now you see that offline classes with offline exam with open book test. So recently I conducted my semester exam with open book test. So I could see that a book was also given, but students were facing difficulty to identify the answer. So we should be very much competitive enough. The scenario is also the same in CPS. When I do a hybridization, that is integration, on the other side, you see the media is focusing that electric car is getting fired. Yes, it will happen. The same happening was done when there was a transition from a telephone to a mobile phones. They said, sir, when we charge a phone, it gets burst. Yes, it should happen. Overcharging, see, when there is a constraint, you should follow the constraint. If you are deviating from the constraint, it becomes a worst case scenario. Is that right? So when we talk about such a system, you see that the scenario is going to play a very important role. So you see that the networking is an important task. Networking with hybridization with Industry 4. So how do we network? See, data is stored. You see the entire Google data is stored in the cloud. Now, everybody started using the Google platform for Meet. Where the data stored? See, free of cost, data is stored. You see the international scenario is entirely relying on Google. Anything if you say, for taking printout itself, everybody started where is the printout shop in a Google. Say where to travel. Anything you want, it gives answer. The same thing with home automation also. I have Alexa or Google in my house. If I ask the Alexa what is the time, I don't wear watch. Why to wear watch? Nothing. Because you ask your mobile phone, you have 3 to 4 phones carrying on the hand. You see that now the hand watch system itself is gone. Even though you say smart, everything is smart on the mobile itself. Is that right? See, some hybridization is there. Similarly, when you get a vehicle, you talk about hybridization in terms of vehicle with electric vehicle as well as diesel or petrol car, whether both the technologies are there. Because we are moving from a transition state of diesel, petrol to electric vehicle. Now you see many of these in Chennai, you see electric vehicle chargers are available. See, the scenario is totally changed. For that, the technology has to be driven. See, I am taking a technology and I am traveling. If my car is having a problem, immediately it gives information to my nearby station. So nearby station has to attend the call, or else you see I am kept as a layman on my road. So that is the role of sensors and actuator to communicate with the networking in a faster scenario to act. So only I said IEEE should take such more initiatives to inculcate standardization in India. That is one of the primary tasks, so that CPS is going to be a powerful tool for farmers, for healthcare, for manufacturing industries, and also for data analytics. See, nowadays data analytics is playing a very important role. So these are all technology for whatever I have spoken, especially with reference to the different UAVs, autonomous vehicles, smart grids, and operation groups in healthcare. And this is the very important thing nowadays we need to talk about. See, whenever there is a technology, there is also attack. See, you see a recent attack happening in a Texas school. You see, many good things are there. There is also worst scenarios are also happening there, for which that is a lively attack for this kind of technology. That is a attack by itself. See, when there is a modernization, people will also be smarter. See, when I say CCTV installation everywhere, now you see the thieves are very much careful enough. They wear helmets, they wear different gowns, and they want to tap these things for hidden scenario. Make the police in a mess. See, in CPS Industry 4, now everybody is talking about automation. See, you see, I think SRM University, many universities has. We also at NIT have. Inside the campus, we will park series of vehicles, bicycles. Students can take the bicycle, and it is very well monitored through a cloud. They can keep anywhere inside the NIT and they can leave. Again, they can come, they can take another vehicle, they can keep on rolling inside the campus with smart systems. Is that right? So the data of the entire event is recorded and shared to a server in the cloud. So if anything is happening, even though we have CCTV cameras, we also have trackers to track where these people are. Am I right? So this is a very interesting example nowadays. Earlier days we used to have bicycles, but now the bicycles are also having trackers. Every tracking is done not only here for animal straying, especially in Coimbatore district, Kunnur district. You see animal straying news are heard. Animal straying is also protected. We have RFID sensor, industry 4C, where it is not right. Wherever you have sensors and actuators, it is applied. Is that right? So this is the thing you should understand. The understanding is application wise, already we are working, especially in with reference to automation. If you go to Chennai Silks shop, that is a textile industry, the conveyor will be moving from 4th floor to 1st floor, 1, 2, 2, 3, 4. That fellow, whatever the package you are getting the 4th floor, he will put it in a trolley in the 4th floor, it comes to 1st floor, they need not carry. So man-machine interface is becoming popular because of the sensor technology and actuators. Is that clear? So now intervention of man is very much limited, time is faster, cost is also improved. So there is no need for hybridization. See, international globalization is happening in India. There at one point you see there will not be any servant maid, the operation of manual labors will be reduced. The entire house is going to be automated with these kind of scenarios. So this is what the physical system, a sensor, control system with actuator. You see a network jam. Network jam will happen inside the control system. See, nowadays, many of the vehicles, whenever we get a car, we say whether the vehicle has cruise control system. What is the importance of that? Why do we have cruise? Yes, anybody? Yeah, to maintain a particular speed. See, especially the state highways. You see, everywhere in Chennai, everything is highway. You should not go beyond 20 kilometers speed to certain districts, especially the highway 70 kilometers. When you are traveling the same situation abroad, you have a cop standing every distance, maybe around 10 kilometers or 5 kilometers. If your speed of the vehicle is raised beyond 70 or 100, first they will caution you, second they will sue the vehicle such a way that you will be made to learn a lesson. So such kind of scenarios, control system is very dominant, especially in automobile. Automobile industries are relying on industry 4. You see that the entire health monitoring of the automobile is done through cyber physical systems. So these are some of the things with reference to control system. Yes. So here, I need to talk about the CPS with reference to CPS security. So what is the CPS security? We see that cyber attacks are increasing every day. Cyber attacks are increasing. You see that a power plant in Dubai was attacked through hackers. See, I am doing automation one side, other side, the people who are against the automation also is very powerful. So I should know what is the target of my enemy. Am I right? Or else, if I don't know, I simply believe technology, everybody will take all these things. Nothing will work. Your enemy should also be taken into task. So that is called a cyber security. So cyber security is nowadays playing a very, very important role, like the firewall. I think SRM has a networking system inside the college. I think they will have a very strong firewall. Firewall in the sense, such hackers will not be allowed to entertain inside the system. But in spite of that, many hackers are entering. Means how to prevent it? Even though there are many cyber attacks are there, earlier days we call this as IP protocol, internet protocol, which says about how the targets are attacked. So nowadays you see that the targets have to be attacked such a way that my system should be resilient enough. Even though there are attacks, my system should not get hold of the attacks. So how to prevent the cyber attacks? Cyber attacks is nowadays very dominant. See, many people, I think many students are there, they do play games, all these things. At last, one fellow will ask something, they will put 1,000 or 10,000, immediately your money is gone. The same thing not only with students, many of the educated people are also doing the same cyber crimes. Cyber crimes doesn't they do play games. They will say that my friend has asked the money and forward it. At last, on the other side, there will not be any. Am I right? So it has happened to many of our phones. So you see that Tamil Nadu police is also circulating such violence has to be prevented through cyber security. Cyber security is also very, very important. So this is what I will get. See, I this actually after I thought of discussing a case different, but this is with reference to smart city project. What we did at Kerala, Trivandrum city, as a part of smart distribution system, we developed a CPS for network design of the entire Trivandrum city. You see that this was the problem. The water crisis is the state-of-art problem. The crisis increases day by day. Whether I have to supply the water based on the demand, whether the demand has to be raised by whom, that is called as smart. So the traditional methods are also there. Obsolete with introduction of the traditional systems with Industry 4 and Industry IoT. So this was our recent project. What we did at what we are doing for Trivandrum city. And the same we are doing for NIT, we are doing for Nagaland city. Last week I was there to prepare a DPS for water distribution. Everywhere there is a problem. See, I have good number of water, especially you know the Ganges, the problem of Ganges, Godavari, Kaveri, everywhere. Water is sent through the river, to the dam. There are serious check dams. At last, if the farmers is not benefited out of the water, it will reach near Kumbugar in Tamil Nadu. Right, the last entry of the point, it will go to the ocean. So we need to know how to store the water. How to, we are getting excess rain. Last 2 weeks we are very excess rains in Tamil Nadu. But if you see the storage level was very poor. Whether the demand has been raised, Chennai, you see many ponds are made suppressed with buildings. Okay, over the pond they are constructing the building. So you see that the storage of the content is getting reduced. We want to increase the demand. For that, we have done a very interesting work, and the same we are doing for Nagaland city also. So the objective is we have developed the system, and the same system we have at for understanding. So this is a very important thing. You have models available, classifier, but at last you see the leakage. The leakage creates lots of things. The transmission lines are several distance, but you don't know where the leakage is. Right? So where the leakage is, unless you know the leakage, then only we can prevent a good storage system. So for that, I think previous session you had a MATLAB demo. We are using the same tool. And the case study is for Trivandrum city, and the same model we have at NIT. So this was the case study we have taken through a UPANET model. You see how network model has been done. The entire zone has been tagged with numbers. See, I should understand like PLC programming. I should know where the nodes are. Here my measurement node is only the flow rate of water, and control where sensors actually is. So nowadays we have so many checkpoints to see that the strategy of the controller is going to play a very important role for the entire division of the Trivandrum city. So you see that
I will send you.
pointer. It will not work. No. Okay. So pointer, so like not do. So some of the you see that we have
laser
a series of events happening with reference to junction and leak. See, as I said, our important objective is to find the leak. See, whenever patients are coming to hospital, nowadays, see, earlier days, everybody said it was the intelligence of a doctor. See, nowadays, everybody says to 95% diagnosis. Instrumentation is going to play a very important role. Only 5% is the intuition of a doctor. Am I right? So the same thing is also applicable here. If you are doing a very good measurement, if you are doing a see, or else you see, you cannot appreciate Uber. You cannot appreciate if I want to get a food, when I am returning from my office, even I cannot get the same food from my wife. If I say I need a coffee immediately, the Swiggy or Zomato fellow tries to reach me within 10 minutes. Am I right? If I want to get a good food, nowadays the more reliability is with the online booking, not with the house. Even I cannot disturb my family asking for a morning tiffin or morning breakfast or evening dinner or evening breakfast, because everybody have their intuition of taking their time. But if I do the same operation in a Swiggy or Zomato or any operation, before my wife tried to give me a food, they are coming inside to provide me what I require. Am I right? So this is the hybrid scenario. I want to taste different food, but I cannot ask my wife every day to give me different food, because unless she is also working other way around, I should provide equal opportunity. Am I right? So that is a state, and that is my strategy, for which we have a very interesting phenomenon. So how we are reliable? The same with the cab booking. So if I want to book a cab, it's very easy, not trivial like before and all I have to wait for auto fellow. That fellow will, if I ask for a 10-kilometer distance, he will say 500 rupees. Nowadays everything is measured. I know who is going to deliver my food, where he is. Everything is tracker. Everything is measurement. If I don't have measurement, you see whether anybody appreciates. See, before you go inside the shop, you are searching the product cost in Amazon. Am I right? Then only you are bargaining with the vendor, saying that Amazon gives a rate like this, how can we charge excess? Am I right? So everywhere measurement and sensors and actuators are going to play a trivial role. You see, any manpower, especially in our NIT, we have a central government, we have around 900 acres of land. Here you are a private university, you have many laborers to see where they are working. I am the chairman of Safety and Security Committee. I don't know how many people are entering in the shift, how many people are leaving. I have to automate, and you see my mobile phone only helps me to see in the shift. If I say that everybody need to give a fingerprint scan, yes, they will do for 1 month. After that, they will say that fingerprint scanner will not work. So I should non-trivially measure them. If I connect my mobile and see whether these people are located, 60% per shift means there should be a 16 number. How to measure? It's a government system. If I am not properly measuring signing, you see next, they will say this as a huge scam. Am I right? So such kind of trivial measurements nowadays is easily possible. Tracking anybody is done through your technology, which is a smart. So the same scenario is applicable. Now you see in Chennai, you have many apartments have MyGate app. There is an app called MyGate. That app does not allow anybody to enter inside house. Okay, I have to give an acknowledgement system whether that fellow is for coming to my house. So such scenarios are made trivially, and we are using the same technology for our campus safety security. Unless I know that fellow whom is entering, we have good number of girls, good number of boys to enjoy inside the campus. They may do anything because our locality is surrounded with village. So everybody is striving for money. So for which intelligence surveillance, everything should be non-invasively done. We have very intelligence, very good intelligence. We have very good detection system. Definitely we need not bother about it. So the same scenario is also done for water distribution. n number of kilometers. You have n number of kilometers, but I can track what is the total volume rate of the flow. So this was a very interesting thing we used to train, and we have a confusion matrix of the data. The entire confusion matrix of the data is stored, and the predictions are done. So prediction means it is like a astrology. You know, especially in Indian scenario, if anybody is going to get a marriage, first and foremost, the boy or girl will not talk to each other. They will take the horoscope of a boy and a girl to a astrologer. He will decide the fate of those couple. He will say that according to his illusion, okay, 90% combination works. Or else he will say 60%. 50-50 means please think. Like that, the scenario is decided by a astrologer. Nowadays, you see the things are changed. First and foremost, the boy and the girl is asked to talk. If they are agreeing, everybody accepts for a marriage. Before and on, Indian system, many good boys and girls will not get because of the third party interference. This is a strange thing, but now, thanks to technology, thanks to innovation, many people came out of it and they say that education is the primary importance, the job is primary importance. Unless if they have a good job, let them talk to each other, get married. So such situation provides. So the same is also happening here. Initially, when we took technology, we had so many several intervention against. See, even when I was head of the this safety and security committee in NIT, you know very well in Indian scenario, you have so many associations. Immediately, my local association will come into me and ask, why you are using a camera to measure us? Whether don't you have fake towers? See, applying this in international scenario is very easy. Applying this in Indian system is very difficult. Now you see everybody is under observation. Government has given a OM. All the institutions should have CCTV surveillance. Yes, they have to obey the regulations. In the entrance gate, you have CCTV surveillance. Especially the ladies' hostel, you should have CCTV surveillance. All these things only make industry 4.0. Or else, if you ask anybody not to do any intervention, this scenario is going to work like a measure. So now you see many of the apartments, you have smart metering. Everybody is paying for the consumption of water they use. Am I right? Unless if you are not doing that, definitely water problem in our country is going to persist. So this is a very important scenario. That is what we are practicing. So for this, you see, this was our experimental setup. What we have, we built a system. Why? Because anywhere you see leakage detection studies are very important. See, I am getting angry because of my inborn qualities and also because of the system at present. If I may get angry at that point, I may react. For the same to the system, it also has there's sudden increase in pressure. My tube line gets burst. How to detect the burst? How to avoid the pressure? How to increase the pressure? All this, only pressure creates the problem. So such a intervention is always hybridization, especially with reference to industry 4. So think about the problem creators. If you have a good number of people creating problem, call them, talk to them. It will get solved. If you say that they are not getting solved, I will also set somebody to hit that fellow, means it becomes a problem creation system. It will not be a problem solution system. So the same thing is happening. What we did, you see series of control valves, meters are there. If excess pressure is given to a water pipeline, it will burst. Similarly, the power grids in our country, you see suddenly my AC gets out, my TV gets, because unless I have a strong grounding and shielding in my apartment. Am I right? If I don't have a strong grounding and shielding problem, these kind of scenarios will happen. You see that the distribution is done, and this is the distribution. What we segment, we fix points. We fix points, fix the numbers, so that any loop is having a problem. So this practice only many of the smart cities in our countries are in intake of this particular technology, because anywhere numbers will play and the numbers are identified with the fault tolerant, easily you can replace the scenario and make a smartness inside the distribution. So such kind of numbering, you see number of junctions, number of reservoirs, number of tanks, everything is playing with numbers. So it becomes a transparency based on the demand raised by the user, water will be given. So based on the demand raised by the user, water will be given. For that, the cost is also sent every month. So people accept the transparency. People accept the transparency and pay for it. If you are not transparent enough, and if you say that no, for this distribution, if you have 12 numbers, I will divide, nobody will accept. Is that clear? So this is the next scenario we have taken for considering the leak at different points. You see that the leak at different points has been configured through CPS system, and from node to one node to another, you see that if the water delay is there, if there is any vacuum creation, immediately it is analyzed, and that particular feeder is increased such a way that this will improve the efficiency of the system. So the same with the classifier. So now everybody started, see, the same artificial intelligence that's applied in India before 10 years, nobody appreciated. Nowadays, you see everywhere, every university started a separate branch on artificial intelligence and data science. So when it was done, I think Devraj has also 15 years before, nobody appreciated. When I visited in 2010 state of California state, all the companies talk about artificial intelligence. Then there was an American Control Conference. At that time, I do talk for farmers with technologies. The entire conference itself got apprehension that how come in India farmers and technologies are working together? Not here, we cannot see such scenarios happening. So this is a very interesting thing we should take up. See, we should take up the technology with intensity. Our NIT is located on the hub of agriculture. If I am not doing anything for the agriculture, there is no point in speaking that I am hailing from Delta district. Is that right? I am also coming from Delta district. Then I become a politician. I should work for technology. The technology is distribution. See, now every plantation is through smart irrigation system. We have to appreciate the efforts. Whatever we are taking, they are also taking to the field. If it is not working, they will come to us. If there is no technology, how they will work? Is that clear? So stakeholders' satisfaction is very important. The stakeholders apply it. Similarly with medical research. Before and all, we could see only papers are coming out. Now you see SRM University, they have a medical college. Hybridization. You see Stanley Medical College, government college. Why? As I said, in India, COVID crisis was very well handled because like post office, we have hospitals. I cannot do the same thing internationally. For that, I should get appointment. Here, the scenario is different. GH, we have all the districts have the GH, all the sub districts have main GH. So entire treatment planning system was very well taken care in our, especially in our country in Tamil Nadu, is because we have a very strong footage. Unless we have these footage, we cannot think of international optimization. Is that right? So you see the same thing we have done for prediction based models. As this is a very important thing when I talked about astrology, it's a prediction based model. We call this as a model predictive control. As I said, marriage between a boy and a girl is decided by an astrologer. Yes, he is a predictor. The same is applied in automobile industry also. What he does, when I am driving a car, I should look on my left mirror, right mirror, and the center mirror. I cannot always assume that my sensor is working perfectly. I can go in 100 km speed. If I hit means, that's all. So the scenario is I should balance and accordingly take a trend. So for that, you see that such models are available, and we have to take such models for the same thing we have taken for the water distribution. One side demand, one side source. Take these two things, hybridize and optimize it. So definitely it will be a solution problem. So these were the validation what we did for Trivandrum city, and as I said, whatever we targeted the SVM and Conan neural network with accuracy and optimized hyperparameters were very well taken for the system of the Trivandrum city and also the same for our pilot. So this is a very interesting linkage detection studies, and for this you can see that we have applied the same for cloud of device. You can see that things with people, and optimization has been applied with cost function. So whatever we were trying to do has to be integrated with CPS. If you are integrating, we will get a very good solution for an application. So this was the hybridized thing, what we did for operational technology with the information technology over my process. And this is the interface what we did, and it has been applied, and it has been proven that even for worst case scenario, if there is a pipeline burst, I can take into consideration that the pipeline burst can be avoided through a industry 4.0 until the scenarios are very well precautionary measure. Okay, so some constraints are always persistent. And you see that she's my PG scholar who is working on CPS with the integration. This presentation was also, I like to appreciate Shani Sharma for this. She has done a very good work, and now she has taken a CPS company too. And you see that these are the models, and when the scenario does not have leak, when the scenario has leak, you see that the case studies reveal that the measurement zones are optimal for optimistic approach. And you see that the data collection points were very well. See here, especially in CPS, data collection is important. Unless I don't have data, we cannot play with troubleshooting of this. So these were the SCADA system we built for IoT cloud and dashboard. And now you see that every region of measurements are done for simulation, and the same thing has been taken for validating with the stakeholder, and in turn the stakeholder validates only the bill is generated. So definitely mathematics, you see that a number of transfer function in number of models we have taken, I've shown for this, and this is for the what for a single bag I have shown for a model predictive control for a single bag, especially for a scenario I have shown. And this is for several control bag too. And at last, you see that MPC reviews are very powerful, especially with reference to CPS. And for anything, you can refer to my first paper on controlling engineering practice on the CPS system, which will give a very basic understanding of the system. So other case studies I have already talked. Other case studies, smart grids and all I have informed, but the thing is that the scenario is what we applied. As I said, the measurement using sensors are very important, and privacy is not the secret. This is a very important key. We should know what is the difference between privacy and secrecy. Until if you are not safe enough to handle the security, the entire system will be fault order. So this is the anonymous for the records. And the attacks on implantable medical devices. So you see that nowadays, especially here, we see a capsule endoscopy. Capsule endoscopy is available. It's like a tablet. If you say industry 4, I am applying for a patient, if the capsule itself is attacked, the patient is gone. Okay. So the technology plays a very important role. So only I am saying that like US or European universities, Indian scenario is like that. Now people are coming inside educational institute for technology. So unless we have a good technology and the respect you get is different. Okay, so this is my notion towards CPS. So it was from different implants. You see nowadays, especially cardiac, you see a pacemaker is inserted with technology. The pacemaker itself is had, you see the imagination of patient is gone. So people are coming for technology. Technology should protect the people. So these are the telemetry attacks right in many of the medical. Scenario 2, which clearly reveals that industry 4 is going to be, and there is a separate code word for medical technology. That is, it's not an IIoT, it's IMOT. It's for medical operational technology. It is going to be separate dealing. So where Many of the hospitals are striving for these things, remote operations, robotic surgery, everything is done. And as I said, you are the integrator for everything. Try to integrate everything, make the CPS as a fruitful. So with this, I like to thank once again the organizers for inviting me. If you have any doubts, you can always ask, because it's a very interesting thing and I have shown a case study. I like to thank Devraj sir because right time and we were working and he was asking. So similarly, I could not say no to him. This would rather I request to the IEEE India to standardize the standards for Indian scenario too, so that it becomes a technology driven scenario. Any questions?
Participants, do you have any queries? You can post your
Please
questions on
ask
chat
questions
box.
because taking lecture is easy. Answering questions from the students feels more happy. Yes, I think there is a question.
Any questions from the participants, online and offline?
Thank you, sir. It was very interesting. Sir, my doubt is that is there any problem that has been identified and especially from the southern region of Tamil Nadu on the side of the electricity board, and how could this cyber physical system help on the electricity board, sir?
Yes, now you see government has initiated helpline. That is also through CPS. See how you have a call center in Chennai. All the calls are received in Chennai. They are responding to the place wherever I am saying which place you are from.
I am from Kanyakumari, sir.
Yeah. Immediately within 10 seconds they are attending the fault because through sensors they are informing through the nodal point and immediately the corrections. So CPS system industry core standards are also operational in Tamil Nadu. Now you see next phase they are changing the meters as smart meters, IoT enabled meters. So that will give a true inspiration of Is that right? See, nowadays how you are paying your bill?
Through online.
See, you're online. You see, the olden days, imagine you have to take your EV card to the person who comes to your house, right?
Yes.
Nowadays, you are not bothered now. Unless we change the meter to smart, it becomes more professional. Now they are doing.
Sir, there is a query from online mode. Which are the tools more suggested for cyber security?
So there are so many tools, and especially what I mentioned, EPANet is one such tool, is which gives the network design with the control environment. Many students have started using EPANet model for many of the modeling aspects and security aspects for cyber security. Any other questions also from online?
Participants, do you have any queries?
Yes. I have one query. Hello, sir. Hello, sir. Sir, can we apply some power system in this?
Even for control, possibly the industry itself is doing it within their own little domains. So the CPS is a complete standardization of the whole thing.
Yeah. CPS will be as a complete because initially when PLC were in place, programmable logic controllers were in place. I remember that 90s, the scenario was totally different. If you are going to get a Siemens PLC, you have to get Siemens driver. After 2000, when IEC was in place, okay, IEC made standardization that any company can be bought by the vendor. The concerned drivers can be installed. The power plant will not be specific to a single vendor.
So CPS is already standardized in industrial.
Yeah, it's a standardized system for industrial.
So there's a proper specification.
Yes. See, like IEEE 802.1, the standardization is also in place.
For CPS.
Yes.
Okay, for India scenario is what you're talking about.
Not for Indian scenario, international scenario I am talking. For Indian scenario, everybody have their inbuilt network security for the CPS. Okay. It has to be standardized. Good question. Good question asked by. That is a very important trivial solution. I said no for especially CPS. It should be a standardization across the globe so that any data by anybody can handle so that it can be done for emergency.
Sir, one question here.
Do we require MATLAB software itself, or there are more open and cost effective?
There are more open source available. Open source available. MATLAB is a tool which many education institutes have. So initially you can learn through that, and after that you can, when we implement, you have to go for open source. If you are going for open source, your firewall, your cyber security should be more.
Yes, one more question from online.
Excuse me, sir.
Kindly explain the statement.
Excuse me, sir.
Yes, attack will not be directly on
Sir, is there
system,
any?
it will be on the cloud. Okay, so any attack will be on the cloud that affects the sensor, actuator, and my control system.
Sir, is there any relevance? Hello, I have a question.
With the confusion matrix and all, especially in what particular platform you have used this machine learning model in your water distribution system?
Yes, my machine learning model was optimistic enough, especially when I talk about the demand raised by the user. See, stakeholder has to raise the demand. If a stakeholder requires a demand, already my model is trained with data. Am I right? So when I say that user is asking for a data, my data should also say that I should acknowledge that I have so many storage facility. So if I define my storage, my stakeholder will know what is my storage, and accordingly they will reduce the utility and they can also raise the demand. Is that clear? So that is where SVM is very important.
Another question from online mode. How do you simulate real-time network using EPANet? What specifications are fed as parameters in EPANet simulation?
Yes, a good question. You see that I have made my entire distribution to an equivalent EPANet model. See, when I have this scenario, my system will accept in terms of digitization in numbers. So that is how my distribution EPANet distributes. And I said now so many tanks, so many reservoirs, so many pumps. Based on that, it responds. Good questions. All are good questions.
So one more question. How to model the attack on control systems?
Yes, how to model the attack? See, we really do not know how the attacks are going to happen. Most of the attacks are soft cyber attacks. Okay, most of the attacks are soft cyber attacks. The entire scenario has to be very well handled that if any intruder, similar to that of a Facebook or Facebook account or my LinkedIn profile, I have good number of students linked to my Facebook. But suddenly you see the same name will be somebody outside trying to enter my Facebook. So it is a soft scenario which is going to attack. So not a hard scenario. Hard scenario is making the soft to hard is very redundant nowadays. Making my soft, using my soft, making my system to get bugged is important. So for that, we should have a very strong productive system, such a way that my control system should be energy efficient. Yes. Any other questions? Any other questions from the audience? It's a very good interactive session. I think there's some. Any questions? See, this is a very interesting field. I think DST also has ICPS division separately. If you are a faculty, you can submit good proposals. And definitely this is going to be a state-of-art technology. And the government has initiated many smart cities project. We don't have manpower to work for that. Please talk to the government, submit proposals, work for real scenario, then only you can apply this. See, always talking about theory and sitting for an ideal application will never work. Take a real case study, work for it, then only you can feel the importance of this particular CPS with reference to industry. So As I said, now our Indian universities are powerful enough to handle such scenarios. They are capable enough, and many students are working, especially in CPS. It's really a good trend for the growth of our country.
Is there any existing security system which is like more powerful, or still the CPS system what seeing right now is
No, see, for servers on the cloud, we have exclusive networks, exclusive cyber secure networks. But we cannot apply that for a general scenario too. See, maybe what I have said in Dubai, the entire plant was affected through cyber attack. The same scenario will not happen in our country because the firewall done by the vendor may be strong.
Thank you, sir. Thank you for the wonderful presentation.
We have one more question from the online session. A broader question regarding the ethical use of CPS. How do we ensure the ethical use of application of CPS? Is this generally left to government agencies and regulation?
See, Government of India is also working on the regulation. I think shortly they will be coming out with a policy for CPS because hybridized automation is prevailing. And as I said, government is also very keen. Shortly they may come out with some standards.
Thank you, sir. I request Dr. M. Sangeeta to honor our speaker. Dr. M. Sangeeta. And next speaker is Dr. S. Bose. He's a professor in Department of Computer Science and Engineering in College of Engineering, Anna University, Chennai.
Permanently deleted.
He has completed his BE CSE from Tyagaraja College of Engineering, ME CSE from Kalasalingam College of Engineering, MBA from Annamalai University, and has obtained his PhD in the area of information and network security from Anna University, Chennai. He has 25 years of experience in teaching, research, mentoring, and administration. He authored 4 books, out of which 1 book is published in Pearson Education entitled on Cryptography and Network Security. His area of specialization includes information security, cloud computing, social networking analysis, machine learning, and deep learning. He has published more than 120 papers in national, international journals and conferences. During 2013 to 2015, he acted as the Deputy Director, Center for University Industry Collaboration, Anna University, and has conducted several Tamil Nadu state level placement program drives for Anna University affiliated colleges. We welcome you, sir.
So it's a very crucial time for reading lunch and some break, right?
Okay, ma'am.
maybe try to listen my lecture. Today's topic is physical communication system. And what is communication? All you don't know that simply transferring information from one place to another place with the help of different devices. And the computation cost and the computation time all are very, very important from the scratch. Now we are in the mobile environment with the help of something like a cloud or internet, whatever it may be. All are having a lot of information. Whatever I am trying to say something, you can easily pick all those information in our mobile itself. What you call the Google is a god, which gives a lot of information about that. Even you can raise many questions to ask for me. Right? So what I'm trying to say, this is knowledge, the informations are available in our hands. Before 15 years back or 20 years back, we don't have that much facility, right? So how it happened? So because of the networking technologies, so maybe you can find that the technologies like first generation network, second generation network, third generation network, fourth generation network, and fifth generation network, sixth generation network. Now seventh generation network was launched for satellite communication in China, not in the commercial level, and so on. So what is the difference between the first generation, second generation, in terms of bandwidth, in terms of frequency, in terms of speed, rate of speed, and so on? And again, how these informations are processed. For example, you have Android mobile. I have some Windows 10 laptops, desktop operating system. I can send email from my desktop to your mobile. How the compatibility is happening? It's not a magic, right? It's not a magic. How the compatibility? Who will take care of this machine to this machine? How the Chinese language is converted to English, and English is converted to something like that, Japanese, and so on. So how is this happening? The interpretations. That's the technologies is going in different directions. So the communication, which gives a lot of things. So they involve something like the artificial intelligence, machine learning, and deep learning approaches. We are bringing the system in a smart way. Now we ever think we have a smart mobile, smart laptops, and smart, etc. Right. So the technologies have plays a vital role. You would have cared about that the network level, for example. The TCP/IP architecture, the OSI architecture, the ATM relay, ATM architecture, frame relay, etc., and the quality of services. With how to implement the quality of services, we are following some few disciplines like PICO or random early detections and so on. So many things are there, right? What I'm trying to say is that the technology starts from mainframe to till now, right? It is moving in different directions. See, we go along with them. That just now I spoke to Professor Devaraj sir. He said that all people know all people know that what you call this. Maybe we can check with some online. Is it okay now? Right. So the technology, that's why I'm telling that the layer concept, and then again you can say that the Wi-Fi, WLAN, and then WiMAX, the GP, and the GSM network, GPRS network. So what is the difference? We have different things, right? Edge network, Neutron network, PMTS network. Will you please that how is this? Every network will have its own properties and then own device components. So one Wi-Fi may be connected with something like a Bluetooth devices. How it is possible? The communications. So everything is implemented. Everything will have a where we have white paper, we have a RFC number, and so on. Right? So today in this class, in this session, I want to give some other brief introduction about the software-defined network. I think many people you might have heard about that SDN, software-defined networking. So what is software-defined network? In traditional network, what we have that every system will have its own operating system, right? Every network component will have its own operating system, whereas still you have problem. So every operating system will have its own behavior, right? So for example, like in a traditional network, if you want to connect with one node to another node or 100 nodes or all the nodes are connected, every people will have its own operating system. So what I'm trying to say, it is very difficult to maintain this network. It's very more complex, right? For example, you are updating some information. Suppose I'm sending some information, the packet may be lost. Then, or you want to upgrade your system. Then, if you upgrade the system, then it should be spread over or distributed over the networks. Is it possible? Yes, it is possible. If it is a small size of network, yes, it is possible. But if it is a large size of network, then we need to have the upgradation. It's not easy to control in a distributed environment. We have to control in a centralized environment. So what is SDN does is used to bring the centralized brain in a single place through which we can easily, very simply, we can write a program with the help of some open source protocols like OpenFlow, through which we can connect all the nodes, and then if you want to, based on our comments, the individual comments, the system should work, the switch should work. The switch should forward the packets. Whether you following or not, I'm not sure. Maybe when I go with the slides, you can understand what I'm trying to say. Right? So this is what I'm doing. So just I want to give the SDN architecture overview and what are the different open source protocols are available. Using the open source protocols, how we have to write a program. If you know Java or if you know Python, if you know C or C++, you can write in your own way. No, don't bother about that operating system. There is a central operating system we have, that is virtual operating system, that is called network operating system. That will take care how to control it. The controller is a main component, which something like that a brain. The other switches, these switches is every switches will have a vendor dependent, right? It's a vendor dependent. Every switches will have a vendor dependent. They have their own software, they have their own logic gates, everything. It's not open. The Cisco will have different configurations, whereas in HP will have a different switches configurations. How these two are communicated? If if they want to update something in the particular switches, then it should be updated in all the places. Then only you can communicate. Otherwise, you can't forward the packets. Am I right? So that's a problem starts. So to overcome those problems, there is a new concept, a novel concept already exists. But many people now they are trying to work in software-defined networks in terms of providing services in a cheap manner, in a more dynamic. So that, which I am trying to explain here. Maybe if you have any doubt, you can ask. Yes, please. Please, so all the people might have give the definition about this, what you call this cyber physical system, CPS. So very simple. The cyber physical system is something like that, integrating the computation. Wherever the computation is, every places, all the places, the computation is some process. You want to use some logic, a plus or minus, whatever maybe, some computation. With the help of what some computers, right? You want to integrate this. What you call this computer components together, that is nothing but the CPS. Right? So the CPS, what is the purpose of this CPS is used to provide
efficient, to provide the result in an efficient manner and the safety manner or in a secure manner. That's the main objective of this. So we can connect this CPS with the, just now I have heard about that the previous session. We can connect with the IoT, we can connect with some other sensor actuators, we can connect with any electrical appliances or any grid appliances, any electronics appliances, anything we can connect through some smart environment. So, but the only thing is our aim is it's very complex. To avoid the complex, where we have open flow protocol, where we have number of controllers. That is also open source. You can implement, you can download, you can implement in your desktop machines, and then you can try to connect with the other systems. Based on your instruction only, the system will work. That's it. Not from the vendor's instructions. You understand what I'm trying to say? Vice versa. You have the controller. You can write your own controller through which you can connect with the data plane. Through which you can connect with the how to forward that packets to the destination from your instructions, not from the vendor's instruction. Vendor's instruction, vendor switches is just like a blind. That's it. Just like a blind. There is no instruction we are not giving it. Just a blind. But we know if you give a proper command, it will work. Based on your instruction, it will work. That's the idea behind this software defined. So we can connect with the SDN with the this CPS also. SDN we can connect with the IoT's cloud and fog or edge, everything. We can connect with all the computing devices also, with maybe the cloud or maybe a fog or maybe edge or whatever, mobile cloud and so on. Right? So this is what the CPS does. Next slide. So this is some possible down here. From here. Previous, not next. Next. So some of the cyber system, what are the requirements? We have to go for SDN is something like that. Security services is very important. So normally I used to tell that it should be like a weighing machine. Service should be in the other end, and then security or safety should be in the other end. We should balance equally. It's not easy task. Theoretically, we can say that it is easy, or mathematically we can prove that easy. But experimentally, practically, it's very difficult. So some unbalance should be there. If unbalance is there, then we can't get the service completely, right? So that's a very important thing. And then intelligence is very important. Wherever, for example, routing table, I think all the people you don't know that routing table where the network information, other information are available, like source address, destination address, source port number, destination port number, the TCP header information, IP header information, and then UDP header information, or some application related information. Number of ports are available, right? All informations are available, fine. But how to use those fields? For example, intelligence means like firewalls. I can write a rule. Those who are coming from this website or those who are coming from this IP address, please drop it. This is my rule. This is my SRM rule. This is something illegal websites, fake phone number, whatever maybe. If the call comes from this number, please block it. Don't send that data to others. So I can write, right? So that intelligence programs, smart intelligence programs, we should write with the help of open flow, with the help of open source code. Open source code is very, very important, right? This is not the commercial one. It's available. You can try to download, but maybe the time is there or not. You can download it. You can download, you can implement, and then you can create a controller through which you can experiment it. You can simulate how it works. Everything is possible. You are familiar with Python? Yes, you can choose Python. Some controller is there. Open Daylight. There is a controller is called Open Daylight. Open Daylight, which is used. You can use Java code. Using open source, right? Open Daylight. So through which what scalability, reliability, security, everything you can implement. I can show some a PDF file, I think you can forget, right? And the compliance and the regulation bound applications, so many things are there. So every compliance is something like that, you have to regulate it, right? So once you got the feedback, you have to regulate it. You have to update it. We can't design the system for time being, it's fulfilled, right? So the customer, the client will give some feedback, and based on that, I have to regularize my rules, and then I have to update it. That's very important. Keep on updating day by day. Even if you are missing in 1 day or 1 minute, which creates a lot of problems worldwide. Please assume that the network is covering the whole world. And what is that high performance applications? That's very important. Performance is very important. Now, before 10 years back, if I want to download some video file, it will take 1 hour, 2 hours, something like that. Now it's not like that. The performance of downloading or uploading video files or audio files or whatever it may be, or live stream, video live stream, cricket live stream, without any inference, without any disturbance, we are getting the live stream as it is. Now online what do you call online process is going on. It should reach like a offline mode without any interferences. So how the performance you can give as it is, whether it is offline or online. So that is possible. That is also one of the challenges in SDN. The competitions and then process, your intelligence, everything is created, and distributed application control and cloud integrations. So that's also an important thing, right? So how you are going to distribute it, your program or programmable code into the particular switch. So how you have to choose that number of switches? N number of switches are there, like our routers. So how you choose the best router? For example, you can use some routing algorithms. So many routing algorithms are available, I think so. Right? I think you are also familiar with so many, maybe first come, first serve, or priority scheduling. Scheduling is there, right? So based on that, you can choose the shortest path algorithm. So how do you choose that this path, and then what is the purpose? That's my big question. What is the purpose to choose this particular algorithm? How you are forwarding the packet from one point to another point without any intelligence in the particular switch. Right? So those things are very good challenges in SDN for this CPS system. Next slide. So now what is SDN? So maybe very basic questions. I start from here. It is software defined networking is something like flexible and agile. It should be dynamic. Flexible, you should not leave with the other part. It should be dynamic. It should be updated. Yes, flexibility is there, and then in the meantime, you are getting good service. Even if you keep on changing your interest, even if you keep on changing your recommendations, right? Like a Google engine. So that should be updated dynamically. And it's very important thing. Separates the hardware and software. That's why I told that whether you remember or not, the switches is something like ideal. The vendor switches or Cisco switches or some other Netgear switches or whoever it may be, right? It's ideal, it's dead. When it's on, it's ready to do some mechanism. That's it. SDN is not a mechanism. SDN will do something which you feel, which you interested, which forward that goes fixed into the switch. Switch in turn forward to the destination based on that your command, like your DOS commands or Unix command or Linux commands. So the commands you got to write some instruction, right? Then you have to execute like a command, and then you have to take a ping program, right? So that's very important. It's very important thing. It separates the hardware and software. That's the thing which I want to highlight here. That's why the name is called software defined network, based on the software, not from the hardware devices. Previously it was vice versa. The traditional network based on the hardware or based on the hardware only, which place based on the hardware only you have to configure. Its administrator will get will be definitely will exhausted. That because every model will update it. Every model is different. Mobile model is different. Upgradation is different. That how this is how algorithmic they are updating on the model and everything. Then how you want to make connections, right? That's a challenge. And network intelligence is logically centralized through programmable SDN controllers. So in the formal way, you can take this. So programmable, you can write a program, and through which you can, what you call this, you can create an intelligence. You can write a rules. If else is nothing but what? Rules. You can write a rules. Or nested if statement. If else is a rule, right? Simply. You can write what are the if else is what? You want, yes, you can proceed. No, drop it. To understand, I am trying to say. You can write anything, number. Say in the traditional program, we have to write number of billions of programs, billion lines of programs. In a hardware level, billions lines of logic gates, you have to write number of codes. In network level, you can write number of codes. Number of codes means in terms of millions and billions of codes, you are right. But here it's not like that. It's like a small piece of code and then comment, and then you can write, and then you can connect, and then you can get the service along with security and so on. So this is, I think, most probably this is very 3 points, maybe generally separate the hardware and so on. Right? Yes. Maybe the traditional one, the traditional network what does a new protocol per problem, and it's a very complex network. Every problem will have a different protocols. Every problem will have a different one solution. But whereas here it's not either. One problem, we can have multiple solutions. Many solutions we can get from SDN. There is no one way to find the solution. So whereas in a decoupled data and then what you call this, the control plane and the program memory. Right? So we can write a program through which what we can decouple the software and then hardware. And error-prone manual configurations. Now, per error, you have to, for example, like the ICMP, which gives the error reports, right? Keep on giving the error reports, reports and other reports and so on. Whereas here it's not like that. Automated configuration is the centralized, wherever the errors come. So once the error came in a particular place, for example, the link is down in a particular switch, the traditional down, then it should be updated in all the places because all are connected, right? Whereas in SDN, software defined network, once that the particular switch is down, it should immediately inform to the controller through open flow. Then what it does is it will give the instruction how to the failure instructions, and which will check the routing table through which whether it is matched or not, where's the problem and so on. Then if it finds the error, then it will relink with the other switches and then forward to the packet to the same place. So that's the thing you have to understand. And then performance, with respect to performance, the limited information and the relatively static configurations. Performance is very important. It's a limited one. So the information you have to send this much only. And whereas that static configurations, not dynamic configurations. So once the switch is there, this is static. They are not like the dynamic post configuration like a DHCP, right? So assume that what I'm trying to say, please come with the lower layer. There are 3 layers are there. We will discuss with the 3 layers: control plane layer, and then management plane layer, management, and then infrastructure layer. So we'll discuss like the OSA layer, TCP/IP layer, and so on. So here the dynamic global control with the cross layer information. The cross layer communication is one of the things, right? What I'm trying to say that the physical layer, the data plane layer, and then the control plane layer is frequently communicate if any features or any points or link is down or up, which will upgrade with the help of this cross layer approaches. So we don't find any feel like the connection is closed or disconnected and so on. And innovation is very important. This is open innovation. This is a closed innovation. Traditional is closed. So the vendor will not reveal all the code information or design information in front of you. The vendor everything is closed community, whereas in SDN is open community, where you can whatever you want, right? Everything is open. You can write and then you can deploy that information to that any device. That is possible. So that's the thing which I want to tell you here. Next slide. This is the SDN general architecture where you have that application, number of applications, and number of applications where so here we have a number of applications. The applications maybe your networking application for topology assignment or configurations or network configurations or any other gateway. You want to create some gateway informations and so on. Everything you can write there in terms of applications. The application terms which connect with the one is called northbound interface. There are two interfaces, northbound interface and then southbound interface. Northbound API and then southbound API. API is application programming interface. So all you the interface will connect with the application, the upper layer with the help of northbound, and then the lower layer, lower levels will be connected to the southbound applications. So what it does is the number of switches are there through which we can generate the channels, and the channel will have each channel will have a different service provider. Every channel will have a different service provider. So the main thing is easy to program. SDN easy to program and then change routing policy on the fly. So you need not to be the particular place you want to come and do it. No, not necessary. You have a desktop machine, you can go it, write a command, and then you can pass the command to the next person. It should be updated all over the world. That's the thing is that's a very simple and flexible, and we can upgrade or update those whatever the instructions you have created in your own policy. We can update the same into the distributed environment, like a cloud or whatever. Next. This is one step, the control program. First one. The first one is the open network interface to the packet forwarding network operating system. The same, some points is repeated, even though if it is repeated, maybe for clarity, right, to get more clarity. The same point sometimes repeated, but in a different way, right? So here we have the control program 1, 2, 3, and 4. So many programs we can write. Control program for X application, control program 2 for the Y application, and control program 3 for Z applications, and so on. Any type of applications that is connected to network OS. Once the network OS is connected, then open interface to the packet forwarding. Here we have packet forwarding alone. That's the role of the switch. That's the role of router. That doesn't do anything. That doesn't choose any routing algorithms. That's why I'm repeating. Just packet forwarding. So what it is open interface to packet forwarding with the help of what? Next. Open flow. For example, this open flow is one of the protocol, open source protocol. Number of controllers are available. Whatever US, if you see China, then India, the number of controllers are available. There are number of controllers. I will try to give some few controllers. Maybe you can download and then implement and then try for your some experiments, and you could show the demo to your friends, right? And here through the open flow controller, at least one network OS probably open and closed source. At least one. Then only you can what you call this. You can connect with the network operating system. Next one. It should be consistent and up to date global network view. Up to date global network view. So people, the traditional it's not like that. It's a local view only which we intend. So whatever the update on a particular page, it should be updated consistently without any break. Next. So SDN is not a mechanism. You should understand that this is not a mechanism like so whatever instruction you have given, that's it, nothing else. Other than we can't do anything, not like that. Like a car, a driver, auto car, auto driver car, how it works. So we can control through this SDN and through some intelligence approaches. So SDN, these are the open flow standards of bound API, centralization of control plane and separate control and data plane. All these are not mechanisms. All these are mechanisms. Sorry, all these are mechanisms. But SDN is not a mechanism. All these are open flow is one of the mechanisms. But SDN is not a. So you using open flow, you can write, right? The standard southbound API, you can create an API. And the northbound API also. Southbound or northbound API, we can connect, right? And there is it's not a mechanism, it's a framework which provides many solutions. SDN is not a mechanism. These are all are mechanism. No. These are the mechanism. It's not a mechanism. It is a framework which provides number of solutions, many solutions. Next. The benefits of SPN is something like that, simplifying network management. So maybe maybe you can understand clearly. Network management is very simple, like managing configurations, managing sending packets, anything, any network phase or uplink or downlink problem is there, channel allocation, bandwidth allocation. So many things are there, right? So all the variables we can easily control through this. And simplifying policy enforcement and network reconfigurations. So we can write our own policy and then we can configure your reconfigure. We can easily do it, not in a fixed manner. Resource utilizations, whether it's memory or CPU or network storage devices, whatever maybe, we can easily use this because sometimes the network resources where the seats are available, many seats are available, right? So we can allow some other people to sit there. So now I can see that these are the seats are available. We can make use of it, something like that. So what happens to utilization? Resource utilization is very, very important. So those people are not getting the proper utilization. We can give the instruction to the other networks. These are the resources are available. Please make use of it. And facilitating network evaluation and innovation. That's why I told that the innovations is very important. Traditional is closed one, whereas here open innovation, it is possible. So day by day, whatever you think, whatever you want, whatever your requirement, you can go get. And interoperability. So, for example, number of operating system is Linux flavor operating system services, Windows family operating system services, applications, and Unix operating system related applications, and the different operating system and the different applications. And you want to send email from Linux operating system to Windows operating system, how it is possible? The interoperability, the compatibility, everything will be easy with the SDN. And the control program can automatically react spurious changes of the network state and thus maintain the right level policy. And then very important thing, the features are fixed actually. Here there is no features. The features is not limited. The features is not valid for a long time. That's a very, very important thing which I want to highlight here. And the community development is also open community and then closed community. Everything is possible. And the longer life products. Life products maybe because it's upgraded, right? Every time it's upgraded, the product lifetime will be good, right? Next. So a number of applications are there using SDN, mobile networks, enterprise networks, and then wireless networks, and what else? Optical networks, and the computing models like cloud, fog, mobile cloud, and mobile edge. These are the applications are available, and we can, through which we can connect a number of uh, uh, devices, and through which we can access number of maybe CCTV camera or something like that, a video the video camera and what else, anything, right? So that is possible through this. And then you obviously you all don't know that what is the role of this cloud and that other computing technologies plays a vital role today, right? Next. This is one example which I want to tell, that is how the auto-driven network works. Auto-driven network works. Auto car. So there is no person. The car will automatically drive, and then you see the curve, and then you see the some obstacles, and then how to take the reverse and so on, speed, etc., right? So like a man. So the self-discover, which means that finds components. So where is the clutch is there, where is the brake is there, and then how to drive this, how to control the steering, and so on, right? So that's a main thing. And then self-configure is something like it's a trending one. Self-configure, like how to predict the what are, so after 5 kilometers, what will be there? After 5 minutes, what will be there? So climate changes, everything is to predict, and based on that, the self-drive, your self-driver, right, will drive the car. And auto manage, that is auto business support system for billing purpose, and then auto OSS, operational support system for provisions. So now, so that's the right. So operational provision like the speed, for example. So in Chennai traffic, you have to the speed maybe 20 kilometers, and the highways you can go for 80 kilometers and so on. The provision is state. So the operational support system will help for this type systems. So here you can write, right? You can write all the whatever the blue jargon word is there. You can write it. Maybe it depends upon that car service provider, right? Depends. All the car will have a different manufacturing, different system, right? And the self-monitor counters and the probes like a telemetry, and the self-diagnosis and self-report to human operator. So we can get the information, and then in the meantime, if it is not controlled by the system itself, the human operator may interact and then do something, right? Something like a interface. And the open daylight, I told you that open daylight is working on network intent composition. This is one type of controller through which what the network intent compensations will we can do it. Right. Next. This is the overall architecture of this SDN. One is the data plane, another one is the control plane, and then management plane. So that's the network infrastructure is there, and through which you can provide the number of applications, number of network applications, and so many abstract level is there, and open northbound API, and through which we can write we can create a network level abstractions. Network level abstractions like for example, how to create a topology, maybe star topology or bus topology or ring topology or mesh topologies. For example, so topologies we can create, and with the help of this southbound, we can create a global view with the network operating system for SDN controller through the open southbound API, which connect the network infrastructure. The next slide. Next slide. So data plane, what it does is forwarding the packet, and it identifies state also where the packet is now, right? So what is the rate of the packet, and then where the state is a ideal state or active state or something like that, push state or pop state or whatever, right? So where it is now, state forwarding, and then keep on monitoring and updating the state, plus along with the packet data. The packet data will have the what is the payload and the header information. The header information, for example, source IP address and destination IP address, source MAC address and destination MAC address, and so on. and forwarding decision. That is the forwarding decision will go ahead. Data plane will do it. And the filtering and buffering and scheduling. Filtering, we can filter based on, for example, the bandwidth should be, if it is more bandwidth, maybe we can filter. And these are the packets or illegal packets, and then we have to filter it. And based on some rules, we should have some set of rules, right? And based on that, to simplify the network, the filtering and the buffering is very, very important. So you can buffer it and then stream it. In some places you can buffer and stream it. Like some queue you have to maintain, and through the queue you can buffer it and then forward the packet to this. And scheduling, obviously, number of scheduling algorithm you can go get, like first come, first serve, and priority scheduling, route robin scheduling, shortest path scheduling, and so on. So those things, these are the some of the functions of this database. Control plane is again one which determines how and where the package we have to forward. That's a how and where. How to forward the packets. That's the role of this main role of as a control plane. And other one is how to route, which route, which routing protocols we have to use it. Reactive protocols or proactive protocols, which routing protocols we have to use for this purpose, for the particular network or particular device or particular operating system, everything we can design. And traffic engineering is another one. So traffic or data engineering, right? Traffic engineering, the data is more, the data rate is high, the traffic will be high, and then which reaches in a particular place, and then which creates bottleneck problems. To avoid that, how to handle it, and then failure and detection and recovery, those things will take care by the control plane. So all the operation almost, that's why we are going to call this as a prime. Next. And then management plane. Next. Okay, next. Management plane, configuring and tuning the network. Right, that's the main thing of this one. For example, the device provisioning, and then what is access control list configurations and so on. And again, the traffic engineering, everything will take care by the management plane. So there are three planes: management plane, control plane, and then data plane, which consists of which creates the framework or the architecture of SDN network. Next. This is another way we can see that the application plane, and where we have two components, service and then application, and the network service level application layer, and the service interface, where we have a different control plane and management plane, and the control plane will have that service and application, and management will have a different application and services. And network devices, the device and resource allocation layer, where we have a forwarding plane and then operational plane. Right, so the same, it works based on this component. Next. So the SD controller, I told that the main thing is used to manage the flow control for network management and then application performance. So that's why the overall, instead of keeping the prime in each and every devices, we bring all those things, all the intelligence in a single place. That's called the controller plane, right? So we can the many books or many proof is there, and then many people are call this is the heart or the brain of the network. And previous one. Here all the policies and routing logics are placed in the controller, and this only teaches the switches how to forward it. Right? These are the thing. The 3 points is for unknown packets. The switches doesn't know anything about it, but based on this controller instructions, it teaches to how to forward it to the destination. Next. So these are these some of the controllers. The controllers are there, like physically centralized controller architecture and a physically distributed controller architecture. Knox, MP, POX, Mass Flow, Rio, Blood Knight, and Beacon, they all are open source. You can, everything will be in terms of like what language is different. And flat SDN control. Flat SDN control, we have a Onix, Hyperflow, Open Daylight, and ONOS, Disco, and Cando. This is a hierarchical system, hierarchical controller. And there are different things that there. Maybe exit from it. Please exit. You exit. Open the setup folder. Last one. Open. Come down. Come down. Maybe I shared this PDF file, which is this PDF file from IIT Kharagpur, right? You can get maybe you can get from the open source, maybe networks itself. So they have given some specific about this controller, some points maybe which help you to implement in your machine. Just I want to give few minutes. Yes, please. So I this figure only I copied and pasted in the in my PPT, where they have given, for example, NOx. Just I want to read it. NOx is the original open flow controller, where it was developed in Nigeria, and this is NOx plus C++ API, right? And the architecture they have given, based on that you can create a socket programming, and then we can create the controller over here. And next, next, POX. The POX is a Python-based version of NOx. This is another controller where it claims you can do number of things in POX. And one more thing is RIO is a component-based open source. We can do number of supporting communication protocols in open flow. The version is there. For example, version 1.0, 1.2, 1.3, and 1.4. Maybe you can correct me. Yes. Net config and then OF config, and so many things are there that is possible. We can implement this RIO. So what I'm trying to say, this is very sample. Similar number of things are. It's not easy to discuss all those things in 45 minutes, right? So just the 45 minutes they have given, and within that, just I'm giving some outline of this SDA network, how it works, what are the controls, open source controllers are available. Using the open controller, you can write a program. So, for example, come down. Yes. Please zoom it little bit. Zoom it. Yes. Yeah. So here NOx is around 6 main features are there. For example, control plane architecture, control plane design, programming language, scalability, reliability, and consistency. For example, NOx, the reference is also given 5.1. Then if you see this PDF file reference, you go to, if you want to do more on NOx itself, you can open that reference file 51, and then you can get more information, right? And it's a physically centralized. The programming language they are using C++, and scalability is very limited. And whereas sometimes the limited is also feasible for my requirement, right? For example, reliability is also limited, and consistency is very strong. For example, performance is consistency is very clear. Maybe the POX is a physically centralized. Second one, you can refer the 56 page number. Sorry, the reference paper number 56, and which uses Python. It's very limited and strong. Whereas if you go to ONIX is a physically distributed and logically centralized. Here, the control plane is flat architecture. Here we can use Python and as well as C. For if you download this one, you can get it. And very good in terms of scalability, reliability is good, and weak in the consistency. And ONOS, physically distributed and logically centralized. That Java we can use. Very good in scalability and so on. Maybe you can take Condu. Open Daylight. Open Daylight is flat. Java, very good in scalability, good and strong. Everything is there. Open Daylight, many people are working using this Open Daylight. I'm not going to recommend, but maybe you try for Open Daylight and then try to write your control. And actually, Condu 31. So we can use hierarchical architecture. C, C++, and Python, and very good. And other things is not possible. Right? Similarly, this is what I am trying to say. Number of controllers are stored to this PowerPoint. So, do you understand what I am trying to say? Right? So, the controller, number of controllers are available in open source. You can download, implement in your desktop machine and connect the devices, connect the network, and control some device. For example, control this video. Resolution you have to change. You have to change the resolution. I have to change the audio. I have to increase the audio, decrease the audio. Right? Your program, driver program. Everything is possible. We can connect IoT devices, number of IoT devices, actuators, sensor actuators. We can control the sensor actuators. For example, just now the previous session said that the meter, electrical meter, we can control it. Right? Monitor it at least. We can monitor. We can write a program to monitor the electrical meter through IoT devices with the help of SDN network through some intelligence approach. Right? So this is what this thing, right? Next slide. So this is the same thing. Main thing is how it works. No built-in features are required. Built-in features is not required, and need to be instructed by the controller. But second, what are the things you have planned to use? You have to the controller should understand what you are trying to say. So interactive examples. For example, the switch one. For example, experiencing link failure. One example, link failure in switch one. What it does using open flow ports, port status message to notify the controller. So through the open flow point one, assume that S1 is link parts of the link failure. Then immediately they inform to the controller through the open flow protocol. That is second step. The third step is it uses disaster routing algorithm for what? So already it is registered or not to be called whenever link status changes. So link status failure or pass or whatever may be, right? If there is any changes there, it should be updated. It is called. The fourth one is this are the routing algorithm access network graph info. So, for example, which is the shortest path? One node should be there. There are number of links should be. So number of links should be there. Number of edges should be there to reach the destination, right? So which one is the shortest path? That graph map should be updated. Once it's updated, next one. The link state of interacts with the flow table. The fifth one, it actually flow table. Flow table will have that all the status. That's which you can go with. And then the controller uses the open flow to install new tables in the switches that need updated. So through the S2 or through S1, we will communicate with the S1, it will update it, and then the link is upgraded. This is one scenario, right? Number of scenarios, number of states we can go, n number of states, n number of changes. So everything is just updated. Next. So everything is open, right? For example, like open source is fast development is there. If it is open, then low cost. And other one is if it is open, fast deployment. If it is open, widespread deployment. If it is open, a de facto standard like a TCP/IP. And if it is open, no limitations. So everything is there. So what about all the countries have no restriction, no rules. All the countries will have their own controller, right? Then how we have to, if it is everything is open, all of the above lead to insecurity. But as far as SDN next slide. So for example, VPN and firewalls are based on secure boundary wall. In the particular wall, the dotted round circle. In the dotted round circle, two things are there. Two things, secure and then insecure. Whereas in a next circle, using SDN, we can bound. There is no border-based security. No border-based security. Everything is out of whatever it may be. It's outside of the your bound only. No boundary security. Security is right. So that's the thing you should understand next. So this is open flow is very important. So SDN architecture, why we need, what is the benefits, what is the advantages of a SDN network, what are the things, what are the layer architecture is there. The main role is the open flow protocol. The open flow protocol for controlling and forwarding behavior of Ethernet switches in SDN network. And now it is used for in all the places, developer side or the organization side or the vendor side. They have their all the people are using this open flow. Next one. So this is another how the message is passing it in all the way. So there are number of things are there. Maybe escape. Maybe go to the previous slide. PDF. No PDF. Just give you some. Everything is there. Please, maybe you can spend 1 or 2 days. 1 or 2 days. You will learn a lot.
Last one.
Last. Yes. Yeah. Pull up. These are the open flow switches messages. There are 3 different kind of switches messages switches are there. One is control to switch. Next. And asynchronous messages. Next one. Symmetric messages. 3 different kind of messages are there in open flow. Please go through this slide. You can understand what are the messages you can use it. Right. Maybe take 5 minutes. Right. So the open flow table looks like this. There are one rule is there. The rule how you can write a rule. For example, switch port number, virtual LAN number, virtual ID, MAC source address, destination, the IP address, Ethernet type, IP source, and so on. Right. Based on that, we can write a rule. I will see some example after this one. And then action. The action is something like that, a match and match action. Match is there and action should be there. Action may be drop your packet or forward your packet, or you can add some other fields and so on. And statistics is how many packets you have sent and how many packets you are receiving in terms of packets or in terms of bytes and so on. And the priority is rule priority. So you have to write a rule for priority. You can give more priority to the gateway communications. You can give a priority for the less bandwidth. You can give a priority for more frequency and so on. So based on that, you can choose those things. Next slide. These are the rules you got to write. So for example, here switching. Switching, we can say that switch port number anything star. And VLAN ID is anything star, and max source address anything star. But only condition the max definition should be 12, 13, 12, 3F, and so on. If MAC address starts from this point, what is that? All the other things are almost all. So packet forward to Ethernet 2. That's the rule. Very simple, right? Only the condition is the MAC address, MAC destination is this forward to this Ethernet 2 or Ethernet 3 or Ethernet 4 and so on. So whereas firewall, the firewall, for example, the TCP port number, all are true, all or whatever it may be, no issue. But only thing is TCP port number is only to drop the packet. If the particular service is coming from the particular source, application, every application, it's have its own unique number, which is called the port number, or the you all know it, right? So if it is some information is coming from this particular 22 port number, please drop the packet. Don't send it to the next level. This is called the firewall. Firewall rule we can write there. Source routing. The source routing again. IP source is starts from 116.2.3. And destination is 202.2. Star. Number of combinations are there. Then forward it to Ethernet 2. For example, virtual VLAN switching. The condition is given. Either you can forward to Ethernet 2 or Ethernet 3. Either or whatever may be. Next. So I told about the open flow messages, how it works. So please go through that. Open 3 messages are there, 3 set of messages. Every message will be entirely different. So you can make use of those messages and then write your instructions and deploy in a particular place, in a particular control. This is overall idea about this. So whatever the packets are coming, the open switch, what it does, the open switch get the packets. The packet will contain payload and IP header, and the client will the switching utility send forward to the respective client based on this what you call this interface command by the controller, right? This is the overall packet processing, how it I guess, right? So hope I think. See what I'm trying to say that traditional networks like whatever may be network, number of kinds of different types of network technologies we have in our hand, whether it is GPS, GPS or Bluetooth or Wi-Fi or whatever may be, right? So where we have every vendor machines will have its own switches and routers. We will have its own programs or software. We'll have its own logic gates where we have write a billions or millions of codes of program using some XYZ language, and it is very difficult to maintain or manage the network. If the size is small, yes, it is possible. If size is very big, it is very difficult to manage or control over it. To avoid that or to overcome that, the new technologies, software-defined networks works that. The software-defined networks mainly is used to separate the hardware part and the software part. Right? The hardware is ideal, the software will have a brain. The brain will be able to deploy in a controller. The controller will using the controller, we can write some programs. How to write a program? Using some open source software. Open source software, number of open source software are available. You can use that open source software through which we can control the switches. The switches will obey whatever the controller says something, it will obey and forward the packet to source to the destination. So number of things are there, and then set of messages and other things are there. Please go through these 2 slides. So definitely you understand that at least at the beginning level, you will be clear, and then try to download some open source, you can download and implement and execute, and you feel that how it works. Okay. Hope I think I am trying to say something. I think you also try to understand something, right? Thank you so much. Yes, please raise your question, please. Because almost I took more than an hour, right? Is it okay?
Any questions from the participants?
Sir, you said that this HDN networking is open source and it's not secure. So how do the industry?
It's not secure. I didn't say this.
It's like you should.
It provides security, more security. That's why I'm telling that 2 circles I draw, right? It's a no boundary. Insecure is outside the circuit. It provides more security.
Okay. So, and my another doubt is, can you brief some points about network intent composition?
Network
intent composition. NIC.
network
Intent.
network intent
composition.
So it's like a network interface card, right? The network interface card is very important, right? For all the computers, NIC is there, right? So through the NIC, we can connect with all the process, right? So we can write a program like work like a NIC.
The questions? Online?
So, a question from the online. How can we use Mininet to simulate the situations and simulate real control system scenarios?
Mininet is we can create it's one of the tool. We can create the what is that data we can create or SDN data. So like NS2 or NS3 or NSKL and the KDD data is already available. We can create the SDN node and SDN communication related data we can create through this Mininet, and based on that we can analyze and then we can control the system. The data structure is very important, right? So that's very important. Unless otherwise you understand the data structure. So number of fields are there. The prerequisite for this course is, for example, computer networks. You should understand clearly about the computer networks. For example, TCP/IP architecture, OSI architecture, TCP getter information, UDP getter information, IP getter information, ARP getter information, RERP getter information. Unless otherwise, it's very difficult to analyze and write a program. This is a basic one, very prerequisite. The language doesn't matter. Yes.
So another question from the online. Can you name the element that will be replacing the existing routers and switches? Can you name the element that would be replacing the existing routers and switches?
Eliminating routers and switches.
Replacing
Routers and switches. No, here we don't have this. Router and switches, replacing router and switches. Without router and switches, we have to forward the packet. It's mean like that. For example, without operating system. Can you run a program? Yes, possible. So I don't understand that particular question.
Another question. How SDN can be used for integrating a multi-interface networks and LAN?
That's why I'm telling. It connects everything. For example, IoT network is there, the GPRS network is there, the GSM network is there. We can connect. Even Bluetooth is there, Wi-Fi is there. Bluetooth is having some people, and then Wi-Fi. WLAN will have some people or nodes. We can connect through this SDN. That's a special thing. The special things are there. We can be able to connect all the networks. Yes, it's possible. Yes, it's possible. 100%. That's a special. So see, we are controlling through this software irrespective of LAN, WAN, MAN, PAN, etc. Irrespective of any LAN, or WAN, PAN. So we can connect with the help of different technologies also, networking technologies. 802.11, 11A or B or C or D or E, whatever may be, right? Or 802.14, 11 or 13. Everything is we can connect. So that's a special about this concept. Most of the research now is going into behind this SDN. We can, because of this question is something like that. How we have to, we can't leave the that's those technology, right? We can't throw my mobile immediately. So I want to connect. And in the meantime, I will sit update it. So with the help of SDN, I can update and then I can use my.
Thank you, sir. Thank you for sharing.
Thank you for listening my lecture, and really I'm pleasure to say something after a long time, after pandemic period. This is the first time I'm giving lecture because of my friend Devarajan. And anyway, thank you so much for your patience and listen to my lectures. Thank you so much. Please, this is the one of those who are working or are interested to work in this platform. Maybe you can communicate. Maybe you can communicate. Maybe you can find my name and other details in the net itself. And doubt, please raise your doubts through my mail or call my mobile. Definitely, I will help. An interesting topic.
Thank you, sir. I would like to request Dr. J. Preeta Murthy to honor the speaker.
Are you able to follow me? Thanks, sorry.
Sorry.
Okay, thank you.
I request all the participants to have their lunch, which is arranged at the back of the hall, and join back at 2:50.
So
You
online
have your, the
participation.
next session is from Act
So
12.
kindly assemble
Devanan
2:15.
Singh Leo on psychophysical systems and MATLAB environments.